I will take a shot. See, yesterday at the end, he actually talked about it, right? So, given the matrix, how do you get the transformation? If you read that part of it, you may be able to get it. So, basically, what have been given is the thing you have to get the transformation of T from the matrix.
Yeah.
So, you can use the basis vectors
Yeah.
and write, the basis vectors and then guess the transformation.
Yeah. The thing is, whenever I am trying to write it with respect to the basis vector, what I am getting is xy, not yz. Okay. So that's why I mean I'm facing some problem. Like you can write t of xyz what you are telling is to write t of xyz in terms of t of 210 and t of 101, right?
Am I audible? Hello?
Yes, sir, you're audible, sir.
Yes, sir. Yeah.
Yes, sir.
Okay. Okay, so today we are mainly going to discuss week 1 to 3 and the refresher week. So I have chosen some problems basically related which problems may be related to quiz problems or the mock which we have already seen in the portal, and we will try to solve those problems, and then along with that we will discuss the concept related to that. Okay, so yeah, so here I have given a problem that some function is given and you have to find the estimated area along the interval 0, 3 using trapezoidal Riemann sum. So can someone tell me what is this trapezoidal Riemann sum?
It is the middle Riemann sum. Not like we have to find that x into that f0. We can the interval size into the mean of the y values at the end of the trapezoid.
Okay, so what does that mean?
That means the area under the curve. That basically
Okay,
the area under the three trapezoids.
okay, so suppose I have a function like this. So this is my axis. Suppose this is the graph of my function and I am calculating the area by dividing it in some sub intervals. So these lines are basically parallel to each other. So I can form a trapezium by that, right? So these are the trapezium which I can draw here, right? So basically we are calculating the area of this trapezium. So this is the distance between the parallel lines, and this is one parallel line and this is one parallel line. So area of the trapezium is basically the sum of the length of two parallel lines and into the distance between that, and we have to multiply half with that. Okay, so suppose this is my a0, a1, a2 and a3. So what will be the first area of the first trapezium? So this is t1, t2 and
A1
t,
minus A0 into f of A1 plus f of A0 by 2.
and half into that, right? So this is the sum of parallel lines and this. So this is the area of the first trapezium. So I can write area of T1. Similarly, area of T2 is basically half of f of A2, or you can write A1 first, plus f of A2, then A2 minus A1, and so on. You can calculate all the trapeziums you are estimating by. Okay. So is there any problem on this concept?
So how did you get area of T1? I mean, half into?
Half into the, so if I have a trapezium, so this is a trapezium, right? So the trapezium has two parallel sides. These two are parallel. So half into the length of this, sum of the length of these two parallel lines into the distance between them. Okay. So here, this is the trapezium T1. So half into this plus this into the distance between them is A1 minus A0. That is the area of the trapezium.
Yeah.
Okay. Got it?
Yes, I
So,
got it.
yeah. So can you calculate the sum which we are estimating in this problem?
Sir, how many problems will you cover today?
Let's see how many problems we can do.
No,
Sir, one
go ahead.
general doubt in this Riemann sum.
Okay, let him finish first. 1 minute.
Okay, sir. Okay.
Yeah, go ahead.
I was saying that like how many problems you have designed for this session? Like I just wanted to know that. Nothing
I
else.
mean, how that will help you?
How many problems you have designed for this session?
No,
Like
is the number matter to you? I mean,
yeah, I wanted to ask something related to the other weeks also at the end. Like if
okay. So I have selected 7 problems in total, so
okay.
that I can cover all the concepts of week 1 to 3. Okay.
Okay, sir. No problem. You can
Yeah.
move ahead.
Yeah.
Sir, can I ask, sir?
Yeah.
So if in Riemann calculation, area calculation, I have seen, sir, sometime in problem, the integration sign with the limit is there, and at the also at last calculate hint is there in Riemann sum. What does exactly that mean? Means if the integration with the interval is given, I will integrate it and get the result, right? No need to use this Riemann sum
No,
then.
if you are integrating, I mean, this is also an integration, right? This is also an integration. But for integration, what we generally do, we take n number of interval, calculate that, and then we take the limit n tending to infinity, and that will give me the same value
Correct, sir.
if we
But
integrate with respect to, I mean, with respect to x in the given interval, right?
no, one of the activity questions, sir, why I raise this issue, uh, because in the problem it is says ki with the integration sign and all the limits are given. So when I have seen that, I try to integrate that and find the area. But in the hint, they are saying ki use Riemann sum this. So that is why I thought, because Riemann sum is approximation and integration is more accurate. So
No, actually, that's my point is when you are taking, suppose I want to calculate this integral. So you can calculate this integral directly from this given limit.
yes.
Or what you can do, the same thing, same result you will get if you divide this interval AB in equal subintervals, then calculate using some Riemann sum and take that limit n tending
No,
to
sir. If it is what you are saying,
uh,
then if I able to divide that area with the n, then n tends to infinity, and in integral with a to b limit has no difference. That's I
exactly.
understand. But in the problem, it is given you take 4 interval, 5 interval, and use Riemann sum, and at the same time.
Then you have asked to approximate this value. We have not asked to calculate the exact value of that. We have
Okay,
to
so
ask you for approximating this integral.
in this type of problem, sir, I will use then Riemann sum, right?
Exactly.
No need to integrate. Acha, and one more thing, sir. Sometimes the norm sign is used.
Okay.
Norm
Norm is basically the, I mean, length of this subinterval.
length of this, and but in the definition of the norm, it is given the maximum of I. You will take delta xi. It means
So
this interval may vary, but whatever the maximum value I will take. But
exactly.
when we are taking the equal value, what does it mean max of I?
Then max is basically everything is same.
Same.
Then max is
Okay.
also the that value, right?
Okay, sir. Go on, sir. Okay.
Yeah.
Sir, is the answer 27?
Okay. 27 you have got, right? Okay. Let me calculate it.
Yeah.
I think it is 24.
Okay.
I got 36.
Okay. So what you have done first? You have to divide this 0 to 3 into 3 subinterval, right? So 0 to 1, 1 to 2, and 2 to 3, right?
Yes.
So for what is the area first? First area is f0 plus f1 into 1 plus half into f1 plus f2 into 1 plus half into f2 plus f3 into 1, right? So this
Yes.
is the sum. This is the trapezoidal sum which we are about to calculate. So this will be basically half f0 plus here half f1 and half f1. So I get f1. Similarly for f2 and then half f3, right? So f is given as x cube plus 3x. So fx is x cube plus 3x. So what is f0? F0 is 0. F1 is 4, and f2 is 2 cube 8 plus 6 14. F3 is 27 plus 9, right? 36.
Yes.
Okay. So half into 0 plus 4 plus 14 plus half into 36. So this should be the sum. So this is 14 plus 4, 18 plus 18. So I am getting 36. Right? Is there any problem?
Yes.
I mean, whoever is got 24 and some 26, can you identify where you have done the mistake?
Yes, sir, I got it.
Where? Where you have done that?
I didn't I multiplied by half for 4 and 14 also.
Oh, okay. Yeah, but that is coming 2 times, so we have to take the whole thing. Okay. Yeah.
Sir, can you just quickly cover the other Riemann sums? Like, what is the difference in that formula? Like, I know one is trapezoidal. There are other 2 types also, right?
There are some types. So one is called right Riemann sum and another is left Riemann sum, right?
Yes.
Those two are really important one. So when we are taking right Riemann sum, so for right Riemann sum, so in that case, what we are doing, basically, we are taking, suppose this is my interval, A0 to A1. This is my first subinterval. So I will take the value at this point, the function value at this point. So for the second subinterval A1 to A2, I will take the function value for this point, the right one. So what I get here, so the first one is f of A1 into A1 minus A0 plus f of A2 into A2 minus A1. Like that we have to do, okay? So this is the right Riemann sum. And for the left one, I have to take the function value at this point, f of A0, f of A1, and f of A2. Okay?
Okay, sir.
So these 3 are the main Riemann sum which we will be asked to calculate. Yeah.
Sir, my question is when there is not mentioned, we have to take right or left one, then what should we have to do?
If you have to use any Riemann sum, then you can do any of the right or left, nothing, no problem. Right, left, or trapezoidal, anything you can use.
Yeah. And sir, if I may add, if there is a 0 somewhere in the interval, you can use that. I suppose interval is 0 to 3, do the left. Suppose the interval is -3 to 0, do the right. So that way at least one will be 0.
Yeah, that is a nice way. But anyway, most of the time, which Riemann sum you have to use will be given. Okay. When you are asked to approximate something, then most of the time it is given, and you know that this trapezoidal Riemann sum give better approximation. That also you have to keep in mind. Okay, so if you want to find for some real life problem, if you want to find some better approximation, then the trapezoidal is the best way to do it, because it will give a better approximation than right or left. Okay.
So, sir, what we have to do in trapezoidal Riemann series?
That's what I have discussed right now, right?
Oh, okay, sir.
Okay, have you joined late?
Yes, sir.
Okay. So you can see it later also, right? In YouTube, that will be there.
Yeah,
So I
okay,
have just
sir.
now discussed the trapezoidal Riemann sum. Okay.
Okay, sir. Thank you.
Sir, here, will you please calculate the value of this right Riemann sum?
You tell me what will be the value of this right Riemann sum?
It will be quite less as compared to the answer that we get with the trapezoidal. Because it
may
will
not
be
be in this
F1
case,
plus
but
F2 plus F3, F0 plus F1 plus F2.
so it will be no. If I am calculating the right one, so the first value is the F1, right? F1
F1
into
plus
1
F2
plus
plus
F2
F3.
plus F3. That will be the value. So here, if you can see, this is
4
36
plus 14
plus 14 plus 4, right? So it is 54. Okay. Okay. So what is the exact value of this? I mean area. So exact
I got
value
it as 33.75, sir.
Oh, okay. So this is fx dx. So if you calculate it, so x cube plus x 3x dx 0 to 3. If you calculate it, what you will get? X4 by 4 plus 3x square by 2 in 0 to 3. So basically, the integral value is 3 power 4 by 4 plus 3 into 9 by 2. So if you calculate it, what you will get? Can you say?
133.75.
33.75. So yeah, you can see that this trapezoidal is more nearer to this value than this right Riemann sum, right? Is it clear?
Function is
Yes, sir.
increasing
right
slowly.
one will be quite higher and the left one will be quite smaller one as
Maybe.
compared
Yeah,
to.
yeah, exactly. The
Function
left
is
one will be
increasing
80.
when right Riemann sum will be greater than middle Riemann sum will be greater than
For
that
increasing function, that is only
if
for
function
increasing
is
function.
increasing, then we can say na like right Riemann sum is the
Yeah,
greatest.
yeah, exactly.
Left
For
Riemann
increasing
sum is
function,
the
that is the
lowest.
case. Yeah. Okay. So is it clear? Everything
Yes,
about
sir.
Riemann sum?
Yes, sir.
Yes,
Okay.
sir.
So if you just remember these points about Riemann sum, then I think the problems which will you will face, it will be okay. I think. Okay. So I am going to the next question. Okay. Yeah. So this type of question is already given in mock. So we are considering a function mod of x square minus 1 in the interval 0 to 4. So here graph is also given. And you have to check whether f is continuous at every point in the interval 1, 4 or not. So first tell me how we can define this function fx equal to mod of x square minus 1. What is the behavior of this function? What is the behavior of the mod function? First tell me that fx equal to mod x. How it look like?
Repeat the question again. Like,
Yeah.
can you repeat what you said again, please?
So at first I am asking what is the behavior of the mod function, mod of x, fx equal to mod
Like it
x.
will be always greater than zero.
It always
takes positive values.
Sir, it is a parabola which is
No.
upward
I am
facing.
only asking about fx
No,
equal to mod x.
that is why I am telling it is a parabola.
Fx equal to mod x is parabola.
No, sir.
No,
I would
x
I would
square
take an
minus
approach,
1,
sir.
no, sir. You have
I
written.
would take
So
an
at first I am asking
It's
fx equal to mod x.
positive when x greater than 0 and negative when x less than.
Sir,
Yeah.
let me give an answer, sir. So in
Yeah.
this case, If x square is less than 1, it will have a different behavior. If x square is greater than 1, it will have a different behavior.
Exactly.
So 1 is the point that we have to worry about.
Yeah, exactly. So for mod function, as we have already seen, suppose f(x) equal to mod x, what we generally do, we can write it in this form, right? So it is x if x is greater than equal to 0, and it is minus x if x is less than 0, right? So here we are given that f(x) equal to mod of x square minus 1. So I can write it similarly that it is
x square minus
x square
1
minus 1 if
x
x
square
square
minus 1
minus 1 is greater than 0, and it is minus of x square minus 1 if x square minus 1 is less than 0, right? So basically if you see it, it is x square minus 1 if x is greater than 1. So if we only consider the positive part here, and it is 1 minus x square.
So we are not considering the condition of x square minus 1 equal to 0.
Exactly. So equal to 0 is this. Yeah. Okay.
Yes.
Yeah. So that's how we can define this function, right? So here we have asked it in the interval 0 to 4. So my question is it continuous at every point in the interval 1, 4? How should we check?
We need to check at the point 1.
Yeah, but what about all other points?
All other point is in interval 0 to 4 is continuous because it is a parabola.
It is
parts
a
of parabola.
Yeah, it is a polynomial function. So it will be continuous at all other points. So we only have to worry about x equal to 1, right?
Yes, sir.
So how can we check?
Right limit and left limit.
Left and right limit.
So we have to take the left limit. So 1 minus fx, this is one thing. And we have to check for right limit also. That is extending to 1 plus. So basically for a graph, for a function, we have to come from left and come from right. If we reach at the same point of the function value, then it will be continuous, right? So can someone tell me what is the left limit of this?
0.
0. Which function we have to consider for left limit?
The second one, sir.
Yeah.
1 minus x square.
When x is less than 1. Right. So limit extend to 1 minus, this is 1 minus x square. So 1 minus 1, that is 0, right? And what about the right limit?
Same, that is also 0.
Which function we have to consider for that?
The first one, x square minus
1.
So this is again 0. And what is the functional value at this point?
That is
f of 1.
minus
f of 1 is again 0. 1 minus 1, that is 0.
0. X is equal
So we can see that the limit, so left hand limit and right hand limit is same. That means the limit exists at that point, and we have calculated it to be 0, and it is same as the functional value, right? So this is the definition of continuity. If the limit exists at that point and it is same as the functional value at that point. So if that happens, then we can say that f is continuous at that point. So it is continuous at 1. Clear?
Yes.
So yeah.
Will you please show a graph for a moment?
We can directly answer this
directly
question
from this
using
graph also we can
If the graph is given, then you can see it directly. But I am
there is no discontinuity, we can directly judge it.
If graph is given, then you can do that.
So how to see from graph?
Yeah.
I mean, how to confirm from graph?
I mean, you can see directly from the graph that there is no discontinuity at any point, right?
Okay.
Yeah. I mean, if it is not clear from even from the graph, then you have to do this calculation to see it.
Sir, just one question, sir. If what does exactly mean the function is defined at a point? So both we need, if we check only continuity, or we will need to check both? I mean, only limit checking is suffice, or that point has to be a continuous to be defined?
No, for define, I mean,
Many
define has
times, sir,
nothing
in
to do
problem
with
is
this continuity or.
many time we saw na sir ki the function is defined at a, or this function is defined in this interval.
I mean that point should be in the domain. That is the main thing for define. Right. Suppose I am giving you a function fx equal to 1 by x. Right. Is this function defined as 0?
No.
So that is the case. This function is not defined at 0.
Oh, only in the interval I will check whether that is exist or not.
That function exists. The function value exists or not. Yeah. That is the point.
And sir, here the graph is polynomial. We can understand ki x square is a parabola, which is a part of polynomial curve. So right hand side of the one and left hand side of the one, both is polynomial. So we are able to drawing the conclusion ki this function is continuous beyond -1 and +1. Okay. But if the
between -1 and +1, it is also
no, right side of the one and left side of the one, the function is continuous.
Yeah.
But if we do not know, is it true for all other functions, means other than polynomial?
No, you have to.
Graph is not given. This is not true, no?
No, graph may not be given. They only give the function. Then.
So you already know some continuous function, right?
Yes.
Some example of continuous function. So if you come across those functions, then you know that this function is continuous, or you know something that it can be written as sum of two continuous functions. Then also it is a continuous function at that point. Right? So all those properties you have to see.
Okay, just give one example when at this function is not continuous. Tell some functions. One example.
Suppose I am taking the floor function.
Okay.
And I am asking you, suppose fx equal to say floor of x if x is greater than 0, and ceiling of x if x is less than 0, okay, or greater than equal 0 here, okay. Then is it enough to check only at 0?
No,
because at 1, 2, all these points there are discontinuities, right?
Okay.
So is it clear?
Yeah, got it, sir. Okay.
So there was a similar question in mock 2. That was, I think, x square minus 4, modulus of x square minus 4 plus modulus of x.
Yeah. So how can you write that function?
That is from again 0 to 4, and at 2 there is a sharp point.
Exactly. So for 0 to 4, that means this mod x does not contributing anything, any difference, right? Because this mod x is always positive. Yeah, in 0 to 4. Yeah. So if it is x is less than 2, what will be the functional value? What can we write if x is less than 2?
4
minus x square plus 4 minus x.
So this is plus x. If x is less than 4,
less than 2.
Yeah, sorry, if x is less than 2, right? So this will be the function, right?
But sir, if it is less than 0, then it will be minus x, no?
Exactly. If it is less than 0, then there is some problem here. But in the 0 to 4, this x is always positive, right?
Positive, yes,
so mod x and x is same.
Yeah.
Right?
Yes, sir.
In this interval, mod x don't play any role.
Exactly. Is it clear?
Yeah.
Okay.
We can write this, right? And once we can write it, then we can solve this problem, whether it is continuous or not.
Could you explain once more why mod x does not play a role?
I mean, what is the value of mod x in interval 0 to 4?
It will be x itself.
It will be x itself. That's what I have written.
Okay.
Right. But if we consider some interval where negative values are also there, then this mod x will play some role.
Okay.
then we should write minus x. If we are considering suppose minus 2 to 0. Okay.
Okay.
So can you tell me what is the function when x is in between minus 2 and 0? When x is in between minus 2 and 0?
Which ones are with
This function fx is this
4 minus x square minus x.
So when x is minus 2 to 0, then the first one will give negative value. So it will be 4 minus x square, then minus x. Okay.
Okay.
Is it clear?
Yes, sir.
Yes.
Yeah. Okay.
So, sir, so just to summarize the approach is write the function for each breakpoint or possible breakpoints, and write the different values, and then calculate the limits at those points.
Yeah,
right?
exactly.
The question is
left hand limit and right hand limit and see whether they matches. If they does not match, then you can directly say that limit does not exist, so it is not continuous. If they matches, and then you have to verify that whether the limit is same as the functional value at that point or not. Okay.
Okay, sir.
So
got it. Thank you.
Yeah. So there are two things. At first, the left hand limit and right hand limit should match, and if they matches, then you have to see that whether that limit is same as the functional value. Then we can say that this function is continuous. Is it okay?
So here the interval is given as 1:4. F is at continuous at every point in the interval 1:4. Then we will say yes. What if the interval is given as 0 to 4?
Yeah, you can tell me what if it is given as 0 to 4. What happens?
Then it we will say that it is not continuous at 1 because there's a sharp point at 1.
No, that for 1 we have checked it, right?
Yes, we have checked it. But
So
if we see in the graph, from the graph, here there's a sharp. So if we draw a tangent as regards
but I am asking about
0 to 1.
I am not asking about differentiability. What you are telling is about differentiability. The sharp turn, the sharp corner of a graph that correspond to differentiability. If there is some sharp corner, we can say that function is not differentiable, right?
Yes. We are just talking about the content. Yes.
Yeah. So yeah, exactly. That will be my.
Can we take one example on differential?
At every point in 1 to 4.
Okay, that is the next question.
Yeah, that is the next question.
Yes.
Okay.
So in the previous question,
yeah.
In previous question, if the interval is minus 2 to 4, then we have to split into minus 2 to 0, then 0 to 4.
Exactly.
Or minus 2 to 0 or 0 to 2 and 2 to 4.
Exactly. Yeah. Okay.
Okay.
Then we have to check for more points, I think. Right. Yeah. So, okay. Next. So continuity is clear. Continuity and limit is clear, right?
Yes.
Yes, sir.
Yeah.
Yes, sir. Yeah. So if I can summarize, the function may be defined, but may not be continuous.
Yeah, exactly.
The function may be continuous, may not be differentiable.
Like, so I have not reached to differentiable yet, but yeah, that's true.
Na? Like,
at
1 it will be differentiable or not? Like,
that is the question now. Yeah.
It won't be, I believe.
Yeah. So you have to give the reasoning. From the
but sir, one
you,
general question, sir. You are given the interval.
Samit, 1 minute.
Okay.
Samit, yeah. Yeah, Tanuja.
So you can see this from the graph itself, right? There's a sharp turn at 1, so that means it's
exactly. But suppose you are not given the graph, only you have given this this function, right? What we have written. So it is x square minus 1 if x is greater than 1, greater than equal to 1, and 1 minus x square if x is less than 1.
You can find left hand and right hand derivative and check whether it is equal or not. Like equal.
Exactly.
It won't be equal.
That we have to do. Yeah. Yeah. Samit, are you telling something?
Yeah, sir. Just this is okay, but one confusion always arises that you given the interval 1 to 4, right? This function. So I am supposed to look from 1 to 4. What is the function, and or I have to also take a consideration beyond the point 1.
No, you don't have to take that.
Then sir, from 1 to 4, the graph is smooth. Every point is differentiable. Because 1 minus, I can't go.
There is a typo. This should be 0 to 4.
Then it is okay. Then it is okay, sir. If it is, sir, suppose if it is 1 to 4, then I will say this is differentiable.
Then you can say it directly, right?
Yes.
If it is 1 to 4, then you can say it directly. But yeah, my point is it is 0 to 4.
Then it is okay. Yes, no confusion.
Also could be 0 to 4. Okay.
Yes, sir.
Yeah. So yeah, so how we can check this differentiability?
First, take both the differentials. So one will be 2x minus 1, the other will be 1 minus 2.
Okay, so if I want to check it from definition itself, then what we should do? Do you remember the definition?
So limit h tends to 0, f of a plus h minus fa by h.
Yeah. So we have to take left hand and right hand limits. So limit h tending to 0, f of a plus h minus fa by h. This is left hand limit, and so h tending to 0 plus, this is left hand limit, and limit h tending to 0 minus f of a plus h minus fa by h. So when I am saying h tending to 0 plus, I am coming from the positive side of that point, and when h tending to 0 minus, I am coming from the negative side, left hand side of the point, right? So can you check what is the right hand limit first for this function? So at 1, a equal to 1.
1 minus na, sir?
No, I am asking about at this point x equal to 1, what is the right hand limit? I mean right hand derivative.
Okay, answer derivation.
Yeah, I want you to just calculate it.
Square 2.
Everyone do the calculation.
H square plus 2h. It's 2.
It's 2. And left side is minus 2.
Yes, sir.
So this is limit h tending to 0, f of 1 plus h minus f of 1, right? So limit h tending to 0 plus, what is f of 1 plus h? Which function should I use? The first one, right? Because I am approaching from the right side of 1. So it will be 1 plus h whole square minus 1. And what is f1? f1 is 0. So this will be my function for which you have to calculate the limit. So it is 1 plus 2h plus h square minus 1 by h. So this is limit h tending to 0 plus, this 1 and 1 will cancel up. So 2h plus h square by h. So what it will give? Limit h tending to 0 plus 2 plus h. And as h tending to 0, it is 2. So my right hand side derivative is 2. What about the left hand side?
It becomes 1 minus 1 plus h square.
So I have to use the second part of this function as we are approaching from the left side. So it is 1 minus, so first I will write down. So it is 1 plus h minus f1 by h. So limit h tending to 0 minus, this is 1 minus 1 plus h square, and f1 is 0. So if you calculate it, you will get limit h tending to 0 minus 2h minus h square by h. So it is
minus 2.
Yeah.
No, how it became 1 minus 1 plus h square?
So
Sir,
we have to
this
use
f
this.
of
1
f
minute,
of 1 is 0, na,
one
sir?
minute. So I have to use this function when I am approaching from the left side of 1, right? So when I am taking h tending to 0 minus, that means, so this is my point x equal to 1, I am approaching from this side. So the function value should be less than 1, right? When x is less than 1, the definition of the function is 1 minus x square, right?
Yes, yes.
And here my point is the x is 1 plus h. So I am substituting that value, okay?
And the denominator sign will not it become h equal to minus h?
No, so I am using the same function for the limit. That's why I am taking f of a plus h and minus f a. Right? If you have to take minus h, then here should be a minus h also. Right?
Okay.
Yeah.
Sir,
you can use either one of them. Okay. So I prefer to use this definition. Okay. Yeah. Yeah, Samit.
Sir, here you have written f of 1 plus h minus f of 1. Then next step you are written 1 plus h whole square minus 1, but f of 1 is 0.
I am only using this function. So what is the definition of f of 1 plus h?
So in the third step, can you put minus 0 also just to be clear?
That is why
people don't get confused.
People get confused. Sir. Yes. Okay, sir.
Okay. So is it clear for everyone?
Yeah, just one question, clear. When we are putting this f1, for that we need to check the continuous, or just we can put, because x is greater than equals to 1, we can just put 1 minus 1 0, or we need
here we can put directly.
Okay.
So yeah, remember, if the function is not continuous, then there is no point of checking differentiability.
Okay, so anyway we need to check the continuity, then only we have
because a function is differentiable only if it is continuous. If it is not continuous, then it must not be differentiable. Okay.
And in some cases they are giving multiple values, like greater than 1, then greater than 2, 3. Okay. In that case, whenever they will ask for that given point, we need to check that point interval, means where it's coming from, the left side or right side. And
Exactly.
Okay.
Wherever you have find some breakpoint, you have to check for that. And see here, for the other points, this function is a polynomial function, so it is obviously differentiable.
Yeah, right. For this function, it's
when x is strictly greater than 1, it is differentiable. When x is strictly less than 1, it is also differentiable. Right?
Right.
Yeah. So is it clear how to check differentiability for a function?
Yes, sir.
Yeah. Is it clear to everyone?
Yeah.
Yes, sir.
Yeah. So should I go ahead? Yeah. So now there is one question, that find the area under the curve represented by the function. So function is the same function. So if x, I can write it once more, x square minus 1 if x is greater than equal to 1, 1 minus x square if x is strictly less than 1. So I want to find the area under the curve represented by this fx, which lie above x-axis in the interval 0 to 4. So what should we do now?
Sir, integration, sir.
0 to 1.
Integrate within that limit.
Point of the integration.
So here there are two parts of this interval where the definition of the function changes. So we should break this interval in two parts, right? One is 0 to 1 and one is 1 to 4. Right? So I can write 0 to 4 by using two parts, because in these two parts the function value will be different. I mean, definition of the function will be different. So when I am writing fx dx 0 to 4, I should break it in two parts, fx dx plus 1 to 4 fx dx. Okay. So for the first one, what should I get? This is 0 to 1, 1 minus x square dx, and 1 to 4, this is x square minus 1 dx. Okay. Is it clear?
Yes.
Yeah. So this is one important aspect when we have such type of function where there are some breakpoints. So when we are calculating the area under that curve, we have to break the integration at those breakpoints. Okay. Clear?
Yes.
Yeah.
So here, this is the integrated area is always lie in this graph is lies in first quadrant. Suppose the integration area lies in first coordinate as well as third coordinate with same area. Then the integration will be 0 or twice
if the
that.
values are same, then it will be 0, because at one side it is plus, another side it will be minus.
And then, sir, to do this type of integration, suppose the function
you just have to calculate the integration. The 0 will come automatically.
Yes, sir. For without calculating
only from 1 to 4, right? Because the question is asking about above x-axis.
No.
So above x-axis is in the interval 0 to 4.
No, but suppose above x-axis is not mentioned, then sure. And the options are like twice the area and 0. Both are there. Twice the area of one part. So which one we should choose?
No, I have not got your point. What?
Suppose there are two symmetric figures. One is in first quadrant and second is in third quadrant. Which if we do this integration like this, it will become plus and minus because it will become 0. Now the option question is asked, what will be the area of the given graph? And it is not asking with sign or without sign, and both the options are given, like twice the area of one part and 0.
Okay.
So which option should we?
So it is 0. I mean, I
always going for the positive. I mean, plus sign of the integration. Correct.
Suppose you are saying this type of function, right? Suppose there is this.
Whenever we are saying area, by that we mean that like it's mod of that value.
So you take f of x equal to x cube.
1 minute. If we want to calculate the area under this curve, so this is positive side and this is negative, right?
Yes.
So
yes.
Okay. Is it clear?
No, yes. But option is like twice the, suppose the one part area of one part is A. So it will be plus A above and minus A below. So A minus A equal to 0. Now the options are twice A and 0 both. So which one should we choose?
That depends on the context of the question. If in the context of the question you have to take area without sign. So the sign of the
that is not mentioned at all. Suppose it is not mentioned whether the area.
If it is not mentioned and you have to calculate only the area, then you have to take in account.
We cancel each other out, right?
Yeah. So in that case, it will be 0.
Okay, thank you.
But if in some context you want to just calculate the area without the sign, then it will be 2a. Okay, it will be clear from the context.
And there's one more question. I mean, this function is defined in 2 separate pieces, right? In certain intervals and all that. So if this function defined in 3 or 4 separate pieces, which is unrealistic, but if it was defined, we would have had to calculate the 4 different integrations of 4 different functions, right?
Yeah.
Together and add them together.
Yeah, exactly.
And sir, integration limit always we should take from left to right, right? In x-axis.
Yeah, definitely.
Otherwise sign. And sir, and sir, for without doing the integration, if the function is an odd function, that is f of minus x equal to minus fx with the same interval area, I can directly conclude that as 0, right?
Same interval area means?
No, suppose f of x equal to x cube.
So when I have an odd function, so this is the definition of odd function. In that case, if I have to calculate minus a to a fx dx,
right,
that is 0. Okay.
But for even function, I need to calculate, right?
Yeah, for even function, you need to calculate. For even function, there is the same kind of thing. So this is fx.
Twice of that.
Actually. Yeah, twice of that. So you have to calculate only for one side. Twice of 0 to a. Okay.
So with this splitting of even and odd, a function is either even or odd.
No, that's not necessary. There may be some function which is neither odd nor even. There can be such function.
Oh, acha.
Okay.
Okay, sir.
Trigonometric functions are categorized.
What about x square plus x? Is it even?
That is question arises and I have written down to ask you because I find something it is neither going in even nor going in odd. That is why.
So that is not a classification. I mean, that is a property of some function.
Okay.
Yeah, some function. There are some functions which satisfy this property. Then we can the first one. So then we can say it is odd. If it is satisfied the second one, we can say this is even. But there may be some function which is neither even nor odd. Okay. Is it clear?
Yes, sir.
Okay. So is it this problem is clear, right?
Yes, sir.
Yeah. So yes, I am going to the next one. Yeah. So a function is given. So the first one is a ceiling function t plus n for some integer n, and the second one is floor of t minus 1 when t is greater than equal to 2. So my question is, if it is given that f is continuous at t equal to 2, what will be the value of n? So this kind of question is also in mock, this some kind of question. So yeah, so for that we have to recall the properties of floor function and ceiling function. So can someone tell me what is, suppose fx equal to floor of x, what does that mean? Just recall someone.
The integer, closest integer lower than x.
Lowest integer less than x.
So it is the integer which is less than x, the just next integer. So f of 1.5 is basically 1. Right? Yeah.
A to a plus 1, a is the closed interval.
Yeah. Yeah. So suppose I am substituting it with x minus 1. Then what will happen?
Previous
the
value.
integer below that.
Below that.
Write that thing like floor of x minus 1.
Previous value than x.
So it is shifted by 1 unit in the x-axis.
If x is 0.5, it become minus 1.
No.
So what is f of 1.5 here? Can you tell me?
1, 1.
0.
No.
1.5 is 1 here.
1.5 is 1.
1.5 is 1.
0.
It is 0.
Oh, f of 1.5. 0.
Right? So it is floor of 0.5.
0. Floor of 0.
Right?
Yes.
So basically what we are doing, we have to take this floor of this function minus 1, right?
Correct, sir.
Right?
Yes,
so
sir.
I can write it as floor of 1.5 minus 1. So floor of 1.5 is 1 minus 1. This is going to give me 0. Okay? Is it clear?
Yes, sir.
Yes, sir.
Okay. And similarly, what is ceiling function?
Integer higher.
Smallest larger than.
Yeah, exactly. So f of x equal to ceiling of x. That means, so ceiling of f of 1.5 is here 2. Right? Now, what is fx x plus 2, suppose? What is that value?
If it is 1.5, that will be 4.
So
f of 1.5 is
4.
Ceiling of 3.5, that is 4, right? So what we are doing here, I can write it as 1.5, that is 2 plus 2, right?
Yes.
Clear?
Actually, it is distributive, no, sir. Seal and floor is distributive, and for number, it is the same value.
So here this is integer. That's the main reason for behind this, right? I can write it like this because it is an integer. Okay. So is it clear?
Yes, sir.
Okay. So now, can you tell me what is the, so here ft is given as ceiling of t plus n, where n is an integer, it is given, and t is between 0 to 2, and this is t minus 1, t is greater than equal to 2. So, and I have to check for which value of n this is continuous at t equal to 2. So basically what I have to do, I have to calculate the left limit and right limit, right? So t2 minus ft, this is one thing we have to calculate, and limit t2 plus ft, this is the right limit which I have to calculate. So at first do this right one, because that one is much easier. So this is limit t tending to 2 plus t minus 1, right? What is this limit? Can anyone tell me?
Actually, we can say limit t tends to 2
minus
plus
1 is 1.
square of t minus 1 we can take outside.
Yeah, exactly. So
That will
what
be
will
1,
be the
sir.
limit? Huh?
1, no?
0.
Floor of t minus 1. So floor of 2 plus is 2, no?
Right.
More than 2. The 2 minus 1 is 1.
Exactly. So it is 1, not 0. Okay.
Yes, yes.
Because we are approaching from the right side of 2. This is 2. We are approaching from the right side. So floor of t is basically 2, right? So right side of 2 means suppose I am taking 2.1. So floor of that is 2, and there is minus 1, right? So it is 2 minus 1. This is 1. Is it clear?
Yes, sir.
Yeah. Now what about this one? Limit t tending to 2 minus t plus n. What is this limit? Now I am approaching from the left side of 2.
2 plus n.
2 plus n.
So for left side of 2, is it 2 plus n?
No.
I am considering floor, right?
1 plus.
Yes.
Yeah. So 2 minus 1.59, for example, 1.95 plus n. So it will
So
be
it
2
is
plus n.
basically limit of t tending to 2 minus ceiling of t plus n, right? Now, when I am approaching from the negative side of 2, I am taking the ceiling. So this value, this ceiling of t, that is 2, right?
That's right, sir. 2 plus n, the value.
Okay. Is it clear to everyone?
Yes, sir.
And n is integer.
And n is integer, yeah. Because this is here n is an integer.
Yeah.
So for the continuity, this limit should be equal, right?
Yes.
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 RHL is equals to LHL.
That's already
Yeah.
N is equal to minus
more
1.
than 1 on the left hand side, so it's not continuous.
Yeah. What?
So on the right hand side, the value is 1 constant. On second side, on the left hand side, it is dependent on n.
So no, my question, observe this question. I want to say if f is continuous at t, what will be the value of n? You have to find the value of n for which it is continuous.
We have to equate it now and find out the value.
Exactly.
Yeah. Is equal to 2 minus 1.
मेरी वॉइस क्या फिर
That gives minus 1.
Okay. So this is 1 minus 2, that is minus 1. So if n is minus 1, then this function is continuous. Okay. Is it clear?
Yes, sir.
Means for the
Yeah.
when limit t tends to 2 plus, the floor of t would be 3 and 3 minus sorry, the floor of t would be 2 and 2 minus 1 is equal to 1. That way?
Can you repeat?
Sir, when we are going for limit t tends to 2 plus, so t is 2, so floor of t would be 2 and 2 minus 1 is 1.
Exactly. Yeah. So that's what I was doing. So we can break this. Whenever we have some integer value shift, we can break this floor function and ceiling function like this, right? So if it is floor of x minus 1, then I can break it floor of x minus 1. If it is ceiling of x plus 2, I can break it ceiling of x plus 2. And then we know how to calculate the limit of this floor function and ceiling function, right?
Okay, sir.
Yeah.
Is it necessary that if it is continuous at 2, that it would be continuous at some other point? It is not necessary, no?
No. That is not necessary, exactly.
Sir, I have a question.
Yeah.
Sir, talking about seal of t plus n, in case if n is not integer, say n is 0.5, the value will be t only now, or t plus 1.
That depends. Then we have to break this interval in some sub intervals where the endpoints are not exactly integer. Are you getting my point? So
Sir,
suppose,
no, sir.
Suppose fx equal to x plus 0.5, floor of that, right? So what is f of 0 in this case?
Sir, 0.
0. But what is f of 0.5?
Sir, 1.
1.
Right. So now my point is, now we have to break with this floor function is not the step is not at the integer interval, right? So now from minus 0.5 to plus 0.5, it is 0. From 0.5 to 1.5, it is 1. Okay. Now it is shifted by 0.5. Is it right?
Yes, sir. Yes, sir.
Okay. Okay. So, is it clear? Floor function and string function and the continuity related to that?
Yes, sir.
Yeah. So, this kind of problem may arise in the quiz. I think there is some problem like this in mock, some of the mock 2.
Yes, mock 1 it is there. 7th question.
Yeah. Okay. So have all of you attended the mock? I mean, have you tried the mock questions?
Yes, sir.
Is it difficult or is it okay?
Anything will be easier than the first quiz, sir.
Okay, I will solve one question in the fast quiz and see whether it was difficult or not. Okay. Okay. So yeah, I have given. Now we come to the critical point and maximum minimum. Okay. So some function is given in the interval 0, 4. This function is given. So at 0 to 2, the functional value is x square minus 2x plus 3. From 2 to 4, the function is 3x minus 3. We have to find the global maxima and global minima of this function in this interval 0, 4. So what should we do first? At first, we have to calculate the critical points, right? So what is the definition of critical point?
F dash of
slope
x
becomes
equal to 0.
So basically,
Or it is
f dash x
discontinuous
should be
at any
0.
point.
That is, or there is another thing.
Discontinuous at any
If it is discontinuous.
If it is this or
that is also important.
If it is discontinuous, not discontinuous, maybe if it's not differentiable, that should be the better way. Okay. So here there is a breaking at 2, right? So should we check whether this function is continuous at 2 or not? First check for continuity, then we will check for differentiability. So what is limit extending to 2 minus fx?
Whenever there is a breaking, we have to first check for continuity at that break.
Exactly.
Necessary.
Exactly.
Because if it is not continuous there, then that will not be differentiable.
That will not be differentiable.
But here, sir, one is parabola, another is straight line. Joining that in 2 means that point is not differentiable.
That is okay. Yeah, you can conclude that from. But suppose you don't know the behavior of the function. Here you know the behavior of the function. Suppose there are some function for which you don't know the behavior of that.
Okay.
Right? Then you should check for continuity first. Okay. So what is this limit?
4 minus 4, 3. 3, sir.
3.
So we have to use the first one, right?
Yes.
So this value is 3. And what is extending to 2 plus?
6 minus 3, 3.
So it is
3.
continuous, right?
3.
Yeah. And what is f of 2?
Of 2.
3, sir.
Right?
3, sir.
3, sir.
It is equals to.
Right? So this function is continuous at 2. Right? So we have to really check about differentiability. Right? So is this function differentiable?
Sir?
Yeah.
Like if in some question, if LHL is equals to RHL, but not if is equals to at limit, then we will say
it is not continuous. Yeah. 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 So yeah. Now my question is it differentiable at that point?
No.
Sir.
Yeah, you can check it directly from the definition also. But here, as Samit has already pointed, that one part is parabola and one part is this straight line. So there is a sharp point, but that may not be always the case. Okay, Samit.
I mean,
there may be some
I have a question. I mean, in this case, we have a parabola and we have a straight line. So obviously, the meeting of those two curves is not going to be smooth. But what if there is a smooth point? So
exactly. That's my
Yeah,
point.
you can say
how
that
will we say it?
because
I mean, from the end of the straight line, we get the turn, a very smooth parabolic
so
turn.
that
We
can
keep-
happen. That can happen. That's why it is always better to check from the definition.
yes,
That can happen. That's why I am saying that don't conclude directly from this breakpoint thing. Okay.
Okay.
This turn may be smooth at some point, so you have to calculate it properly. Okay.
yeah.
Okay. So what about this case? Is this case in this case whether this turn is smooth?
Which one, sir?
I mean, my question is f differentiable at 2?
I don't think
We need
so.
to check
We
it.
should
Then.
check it now.
So let me
Because
check
the
it.
slope of the tangent is coming different.
Exactly.
2x
The
minus
slope will
2
be
and 3.
exactly. So suppose 2 plus, this is 2 plus h minus f of 2 by h. What will be this? So for 2 plus, it is basically 3x minus 3. So 3 into 2 plus h minus 3 minus f of 2. F of 2 is 3, right? And this h tending to 2 plus. So this is h. So what is this? Limit h tending to 2 plus 6 plus 3h minus 6 by h. So it is 3, right?
Yes, sir.
And what about the left hand derivative?
Sir, here you are just writing h tends to 2 minus. In previous, you write 0 minus.
Yeah, exactly.
Doesn't mean that is
I
not
mean,
good.
this is for the point.
Okay.
Oh, sorry. This should be 0 plus.
Previously, we did try.
Yes, sir.
So what is f2 plus h here? So we have to take the
X
first function, right?
2 minus 2 plus h.
So 2 plus h whole square minus 2 into 2 plus h, then plus 3, right? And then f2 is minus 3. F2 is 3, so it is minus 3 by h, right? So if you break it down, what we will get? So this is 4 plus h square plus 4h minus 4 minus 2h, and 3 will cancel out. So this, right?
H square plus 2h. 2.
So this is h square plus 2h by h. So limit h tending to 0 minus h plus 2, and this is 2. So clearly these two limits are not matching. Left hand derivative and right hand derivative does not match. So this function is not differentiable, right? So 2 is a critical point. Okay. So is there any other critical point?
Minus is it 2 or 4? Limit h tends to 2 minus. We are getting 4, right?
No. 2. Not as this is not 2 minus. This is 0 minus. I mean. Yeah.
Sir, in videos, professor has solved for all breakpoints, including endpoints.
I am coming to that.
There, this is not explained. The thing we are doing now, critical point check and the differentiability check, that is excluded in the videos. It was not there. He solved two problems.
No, it was there.
No, sir, it is not there.
It was there.
Is there?
In the tutorial part, it was here.
Yes.
Yes.
Yeah, when we are asking for global maximum minima, you have to check for the endpoints. Okay.
Yeah,
if you only asked about the critical points, I mean for the interior points, local maxima, local minima, then you have not to check the endpoint, right?
Okay.
Yeah, I think you are talking about the local maximum minima.
So in local, we do not include breakpoints, and
no.
the endpoints we do not include. Yes, that's true.
Yeah.
In
So
global
whenever
only
we are
include.
talking about global maximum minima, we have to check for the endpoints.
Yeah. No, we check the way we have writing in that is we are checking whether it is a critical point or not. We are coming to that conclusion. That part they excluded.
No, that is from the lecture.
No, in that particular example. Anyway, sir, we'll go through this.
Please go through
No,
that. I think it's in the lecture.
Yeah,
it confuses further, sir, because what we are not checking for the local and global, it's that doesn't
So
means
1 minute, 1
we
minute.
check for
So,
everything, na sir. What
no.
is some
No, no,
because
no, no, no.
sometimes local
1
maxima
minute.
become global.
1 minute, 1 minute. So when we are only talking about local maxima minima, you have to check for the critical points. So what are the critical points? All those points in the interior of the interval. We are not concerned about the endpoint where f dash c is 0 or this point is not differentiable. I mean, at those points where the function is not differentiable. Those are the critical points. And for local maxima and minima, we have to check only for those. Okay. But when we are talking about global maxima and minima, we have to include along with this critical point the endpoints also.
Yes,
Okay.
sir.
Is it clear?
Yes,
Sir, actually, sir, suppose f of x equal to minus x square with an interval a to minus a. So if somebody is asks me what is the local minima maxima, so at a minus a and
No,
plus
you don't
a.
have to check for minus a and plus a.
No,
You have
that
to check f dash x equal
itself
to 0.
becomes
That's
the
what
local
we
minima
will
and
do.
global.
No. That's the point. For local maxima minima, that means it has to be an interior point. We are not concerned about the boundary point. Okay.
Acha, okay.
Is it clear?
Okay.
The boundary points are only included when we are talking about global maxima and global minima. Okay. Local means there is a local property in that region. It has to be minimum. So the boundary point does not satisfy those things. Okay.
Okay.
Sir, for local maxima minima, it will not have square brackets.
What does it square bracket?
Like it will not include the boundary points.
That's my point is for local maxima and minima, whenever you have to find the local maxima minima, you are only concerned about the critical points that exclude the boundary point. Okay. Because the definition of critical point is if is either f is not differentiable on that point or f dash at that point is 0. Okay. The tangent at that point is parallel to x-axis. Okay. These two are the definition of critical points. And local maximum minima occurs only at the critical point. We are concerned only for the critical points. But when we are asked to find something about global maxima or global minima, we have to take the boundary points into consideration. Is it clear?
Yes, sir.
Okay. Okay. So here, what are the critical points? So 2 is one of the critical point that we have found. Now, is there any other critical point? I mean,
Yes,
where
x equal to 1.
So from where you have got that?
First equation 0 to f
So
dash
if
x.
I take the f dash x for the interval 0 to 2, this is 2x minus 2, and for the second x greater than equal to 2, this is 3, right?
Is it 3 or 2?
The second one is 3, right? 3x minus 3.
3, yes. 3.
So it is greater than 2 maybe.
Yes,
at
3,
2
3.
it is not differentiable. So it is greater than 2. Okay. So this can never be 0. This is a constant function 3. So this can be 0 at x equal to 1.
1.
So x equal to 1 is also a critical point.
Yes.
Right? So we have two critical points.
1 and 2.
1 and 2. And as we have to check for the global maximum minima, I have to include the boundary points.
Yeah.
Okay. Boundary points is 0 and 4. Right? So we have to check the function value at this 4 point. Okay.
The function is broken, I believe. There must be another point, isn't it?
That is 2. That's what we got 2, right?
0, 2, and 4.
So that's why I
One is
mean
also
0,
there,
2, 4, all these points are there, right?
Okay. 2 is also included. Yeah.
At 2 it is not differentiable. That's why we have included it. Okay?
Yeah.
Okay.
Sir,
yeah.
Can you please tell again why we have done double differentiation for this critical point?
I have not done double differentiation here.
Like for f dash
I will
2x.
come to double derivative after this. But for till now, I have not double derivative, right?
Single, you have done single differentiation, right?
Because I want to find the critical points only. Now, what is this? What is f of 0? F of 0 is?
Put the value
3,
there.
right?
0. Yeah.
Yeah.
3.
F of 1?
F of 1 is 3, 4, 2.
So 1 minus 2 plus
2.
3. So it is 2, right?
Yeah.
Okay. F of 2?
2 square minus 4, 4, 3.
No,
3,
f
sir.
of 2 is this part. So f of 2 is 3. We have already calculated it earlier also.
Yes.
And what is f of 4?
That is 4, 4 3s are 12 minus 3, 9.
11.
9, sir.
9.
3x minus 3, right?
We have
That
to
is
follow
9.
respective function.
Okay,
Yeah.
that's the second one. Yeah.
Yeah. So for 0, 1, 2, and 4, we got these values. Now, can you tell me what is the global minima? Global
1.
minima means
X
the
is equal to 1.
minimum value of this. Right? So it is
Global
1.
minima does not exist.
Huh? Why?
X is equal to 1.
Yeah, the global minimum value is 2, which is occurring at x equal to 1.
1 is giving us minimum. So that is
Yeah,
global.
exactly.
Yeah.
Samit, why global minima does not exist?
Sir, go to the equation one more, sir.
No, actually, he's getting
Oh,
confused.
okay. Sorry. The
Sir,
limit
do
I
you have
consider.
to,
Okay.
sir, do we have to double differentiate the function?
No, if we want to
That is
check
for
only for
maximum
the
minimum,
global
not
one, we don't have to go to double derivative, okay? For global one means we just find the value of this function at these points, at the critical point and the boundary point, and we have to check the minimum value of the function at those points, okay? That is global minima, and the maximum was the global maxima, okay? So at x equal to 4, this is global maxima. Now the double derivative things comes in the picture when we have to see whether it is local maxima or local minima, okay? That we have to check only for these 2 points at x equal to 1 and x equal to 2.
Yeah.
Only
So
for
even,
these 2 points we have to go to the second derivative. Okay.
Even here we don't need a double differentiation because we know that
exactly.
between 0 and 2 is a continuous function. So if f of 0 is 3, f
But
of 2 is 3,
if
then
I can
we
go,
know 2 is the local minimum.
Yeah, but still if want to see what is the, I want to discuss it basically. So f dash x is 2 and this is 0, right? If this is in between this interval and if x is greater than 2. At 2 the function is not differentiable, so there is no point of taking that into the account for double derivative also, because it is not first derivative. There does not exist a first derivative. Okay. Okay, so when f double dash x is greater than 0, then that is minima, local minima. When f double dash x is less than 0, then it is local maxima. Okay.
Okay.
Is it clear? So see, at x equal to 1, that is the first one, right? F double dash x is 2, which is greater than 0. So it is local minima. Is it clear?
Sir, in case the second derivative of x for x greater than 0 less than 2 is minus 2. In case. So that will become a maximum point.
That will
So
become
our
a
minimum
maximum
point will change to 0 and 2 because both are having 3. Then that will become a maxima, na? If it is x, f double dash of
it
x
will become a
minus
local
2, that will
maxima.
become
Yeah,
a local maxima.
Yeah. But local maxima does not mean it is maximum for all the function. I mean,
yes. Now considering that in the same example, sir, scroll below, please. Below, lower side. Again, little bit. Yeah, this 3 minus 2, 3 and 9. That will be now the values. No, it will be 2 only because fine. So in that case, local minima will not be 2, na?
No,
if we get minus 2 here, that will be the maxima point, na? So what will be the minima then? Because 0 and 2 both are giving me 3.
That does not necessary that always minima has to exist.
Okay.
Yeah.
Okay.
Got it, no?
Yes.
So observe that. So suppose
f dash x is equal to 2x minus 2 and 3, na? And f double dash x equal to 2 and 0.
Yeah.
This like actually you have put double dash. That's why I was getting confused. Like, here f dash x equal to 2x minus 2 and 3, na? Like this one.
Your voice is breaking, so I am not getting you properly.
So from where we have get the critical points? 1, 2.
So we have to calculate f dash x, and we have to make f dash x equal to 0. And that is one thing, and all those points where f is not differentiable. So at 2, f is not differentiable, we have checked it. So 2 is a critical point, and at f dash 1 is 0. That's why 1 is a critical point, and there is no other critical points. Okay.
So suppose in the function.
Now 1 minute, Samit, is it okay?
Yes, sir. So can you quickly say what is the saddle point also?
So I am
Sir, before that, see, there is no need to find out this f double dash now, because we are going for the checking the local maxima, local minima.
We are going to check global maxima and global minima.
For this problem particularly, there is no
global
need to
maxima,
find out
global
f
minima
double
we are
dash.
checking. Yeah.
Sir.
Yeah.
Sir, if there would have been 3 breaking points, then we would have by chance then 3 critical points.
Breaking point does not imply that it is a critical point. It is a critical point only when it is not differentiable at those points. If it is differentiable, then it is not critical point.
Okay.
I mean, it may be a critical point if at that point the derivative is 0. If that case occurs, only then it is critical point.
That's what I was asking.
Yeah.
From that, we can put the derivative is equals to 0, and then we can find that critical point.
Exactly.
In mid, like we have done between 0 to 2.
Exactly. Yeah.
Okay. Thank you.
Yeah. So suppose I have a function like this. So okay, I have a function like this. Okay. So these points, this is a local maxima. Okay. This is a local minima. This is a local maxima. This is local minima. So observe that this minima is greater than this local maxima itself. Okay. Local minima does not mean the function value is least at those points. That does not mean at all. It can be greater than local maxima. Okay, because local maxima is the maximum value in the locality of that. Okay, is it clear?
Yes, sir. Here the term local, can we take that as a somewhere equivalent to the limit concept?
What is local means in the neighborhood of that point?
Local means, sir,
subinterval of the main interval of the equation. We are just
what does it mean? It means 1 to 4 also a local, 1 to 9 also a local.
No.
If the function is defined between 1 to 4, 1 to 4 is the bigger one. 2 to 3 is local.
Or if you define key, whenever there is a change of slope is happening, with respect to that local.
The point. Exactly. That is the local maxima and local minima, where there is a change in the slope. It is positive to negative or negative to positive. That is the point. So what does f dash x is 0 means? That means the slope at that point is basically parallel to x-axis. So there must be some change to that, right? Because it has to go from positive to negative. At that point it becomes 0, or it has to go from negative to positive, and that point it becomes 0.
Basically a turning point.
Yeah, exactly.
Right.
So yeah, so local minima can be greater than some local maxima. Okay, as you have seen in this graph. Okay.
Yes.
And the saddle point is not a turning point. Okay, I mean there is no change in slope.
Here, like at x is equal to 2, like there are 3 points now, 1, 2, and 3. 3. Okay, like so here f double dash
1, 2, and 3.
1, 2. Here, could you please slide it down? Like I want to here like at point 2 the f double dash x is coming 0 now. Like
no, f double dash 2 does not exist because f is not differentiable at 2. So there is no point of checking for double derivative.
Okay.
The first derivative does not exist at that point. So how can second derivative exist? Okay. Is it clear?
Clear, sir.
Okay. For example, is there a saddle point in this question?
Sir, may I ask you one difficult?
1 minute. Yeah, go ahead.
Sir, If the function is not continuous at some point, then can we say that point is a critical point, or can we say?
I mean, if it is not continuous, then it is not differentiable at that point.
Yes.
Because differentiability
Like if
needs
we take
continuity.
a floor function, then for floor function, can we say we have maxima, minima in a particular interval?
Exactly. I mean, all those points which are integer points. So suppose I am taking floor of x. So all the integers are critical points.
Okay.
Okay. And there is no other critical one except integers.
Yes.
Okay.
And then it is discontinuous as well.
It is discontinuous at those points. And if you take the differentiation at each interval, every time you will get 0. Right?
For all the points, right?
For all the points. So all the points are critical points there.
Exactly.
Yes.
Okay.
Basically, there is a unique tangent at all those particular points. So that is why we are getting.
Exactly. Yeah.
Okay.
Yeah.
So can you again repeat for what are saddle points?
Yeah. So I am coming to that. So for saddle point, this tangent is parallel to x-axis, but there is no change in slope. I mean, there is nothing going from positive to negative or negative to positive. That is the saddle point. Okay.
So in the graph, can you explain global maximum?
So once again, can you repeat what saddle point?
Yeah. One. So okay, let me draw it here. So suppose okay. So I suppose this is the graph of the function. So see where this slope is coming parallel to x-axis. So at this point slope is parallel to x-axis. At this point this is parallel to x-axis. This point is parallel to x-axis, and here, so I am not drawing it properly. At this point the slope is parallel to x-axis. Okay. So all those turning points where the slope is changing from positive to negative or negative to positive, that means those points are turning points. Those are basically correspond to some local maxima or local minima, right? So there are 4 critical points: this one, this one, this one, and this one, right? Where the slope is parallel to x-axis. But among these 4, these 3, the first 3 are basically where the slope is changing. That means there is a turning point. The slope is either going to positive to negative or negative to positive. So all these points are corresponding to local maxima or local minima. But for saddle point, what we can see, there is no turning occurs, right? The slope does not change. The slope is going to 0, but the slope does not change from positive to negative or negative to positive. Okay, so those points are basically saddle point.
That is, function continues to be either increasing or decreasing at that point.
Yeah.
So here it is negative to negative.
If the function
here it is negative to negative, exactly. Yeah.
Yes. So if it is negative,
so either it is
decreasing function, it continues to be decreasing.
Either it is decreasing monotonically or it is increasing monotonically. Then at that point, this is saddle point. Okay.
And sir, how to take that?
Mathematically, how will we catch the saddle points?
No, for saddle points, I mean, the process we know till now is basically you have to look for the graph only. There is no other point you can check.
Mathematically, we can't do it.
Till now, what we have learned, we cannot do it. Okay. There is some way,
I mean,
but that
if
is not
double
in the
dash.
Inflection point, that thing is the inflection point and
inflection point and saddle point are same.
Okay.
Yeah.
Sir, if double dash x, if it is 0, then that is
then it is not conclusive. Then it is not saddle point. It is not conclusive. By checking double derivative, if it is coming 0, it does not conclude that it is saddle point or local maxima, local minima. It is inconclusive. But that does not imply it is saddle point.
Why? Like
for some maxima minima, it can be 0 also.
Like if f dash
double dash can be 0 for some maxima minima.
Yeah, f double dash x can be 0 for maxima and minima also. That's why f double dash x equal to 0 is an inconclusive proof. Okay.
And then
it confirms maxima minima when it is greater than 0 and less than 0. But if it is 0, we cannot conclude whether it is maxima or minima or saddle point. For some maxima or minima, that double derivative can be 0. Okay. So let me write it down here.
We can. Okay. Yeah. Sure.
So let me write it down here first. So suppose this is 0. That means C is critical point. Okay.
Critical point.
And for critical point, there can be 3 cases: maxima, minima, and saddle point. So these are local. Okay. Maxima, minima, and saddle point. These 3 cases can occur. Okay.
Okay.
Now we generally check for f double dash. If f double dash C is greater than 0, it is maxima.
Minimum.
Sorry, it is minima, right?
Minimum.
It is minima. F double dash C less than 0, it is maxima. F double dash C equal to 0, this is inconclusive. That means it can be maxima, minima, or saddle point. We cannot conclude. Okay.
Okay.
Then we have to take help from the graph. Otherwise, we cannot do that.
So when we are concerned about this course, so the concept of saddle point and pointing out or finding saddle points is only going to come whenever we have been provided a graph, right?
Yeah, or you have provided some function where you know the graph of that function at that point.
Okay, some known,
you know
like
the behavior of the
cubic function has a saddle point at x equal to 0, right?
Because you know the behavior of the cubic function at x equal to 0.
Okay. And otherwise, we'll only encounter maxima, minima, and all that stuff. Double dash C will be either greater than or less than, not equal.
Yeah, exactly. So
never equal,
for
right?
cubic function, what you have just now said. So let us do this. So what is f dash x? F dash x is 3x square, right? So at 0 is a critical point, right?
True.
So you can conclude 0 is a critical point from here. Now what is f double dash x?
6x.
6x. So f double dash 0 is 0. So from this point, you are inconclusive. You cannot conclude whether 0 is a maxima, minima, or saddle point. But you know the behavior of this function, right? This f dash x is 3x square. So this is always positive, right?
Always positive, huh?
So slope does not change for x cube. X cube always increasing, right? If dash x greater than 0 means it's always increasing, right? It can never be negative at no point, right? That's why you can conclude that 0 is a saddle point, because there is no turning point. But you know that 0 is a critical point, so it cannot be a turning point.
Visualize the graph, just because we know the behavior of the graph, we can say that 0 is a saddle point, critical point.
But for x cube, even you don't know the graph. Suppose you don't know the graph of x cube.
Okay.
The argument I am giving, is it clear? That f dash x, this is always greater than 0, right?
Yes.
So that means it is always increasing function. The slope does not change. There is no turning point, right?
But 3x square equal to parabola, no?
So what does that mean? So it is slope is always 0, greater than 0, right?
Yes, slope is always greater than 0.
3x square can 3x square be negative somewhere?
Never.
No.
Never. So it is always greater than 0.
To be 0 for all real values.
Exactly. It is always greater than 0. Okay. So this x cube, this is an increasing function throughout the real number. Okay.
That is true.
There is no turning point of that curve. There is no turning point for x cube. Okay.
So that's always increasing.
That means there is no turning point, means there is no local maxima or no local minima. Only saddle point is there. So 0 is the saddle point.
But sir, can I take it this way? If I suppose f of x equal to x cube is the given function, it is the graph we know. Now f dash x equal
that's
to
that's my basic
f dash
argument.
x
If you
equal
know
to
the graph, 1 minute, Samit. If you know the graph, that is okay. But I am saying that even if you don't know the graph, can we conclude that? Yes, we can conclude that. That's my point. Is it clear?
Okay.
If you know the graph, it is okay. You can really conclude it from there.
Like if f double dash x is equal to 0 or something, like even that higher it comes, like if at odd derivative it is 0, okay, then we can't conclude anything. But if at even derivative it is 0, then surely it is the saddle point. Like,
what does it mean?
Means
so
like if
he's saying, sir, if you take x to the power 4 instead of x cube.
Okay.
I am saying that, like, for saddle point, if if odd derivative is 0, like f triple dash x, f5 dash x, or f7 dash x is 0, then you can't conclude anything. Okay, it can be anything. Okay, but if even derivative, the first means while you are going on, like first even derivative is 0, that means that it is a saddle.
That's why we are saying only just focus on first derivative and second derivative for now. Okay, you don't have to go beyond that. Okay.
So in this same equation, if x to the power 4 is there, then f dash x equal to 4x cube, then we can't conclude, sir, this is greater than 0.
Yeah. Then you can conclude that. Yeah. True.
With the same setup, I am nowhere to able to say.
Exactly. Exactly.
Okay, sir, carry on.
Okay. So yeah, that will give you another option. So for fx equal to x power 4, so again 0 is a saddle point. 0 is a critical point, right? Because f dash 0 is 0. Now what is f double dash x? It is 4x cubed 12x squared, right? Again this at 0 it is 0, right? But you know the graph of this function x power 4. How the graph look like?
W
it mean upward quadratic.
X square like, but just the curved upward more.
More wider
and more wider, yeah.
Yeah, let me
long base u.
One minute. So let me go there. This is the function, right? This is the graph of x power 4, right? Can you see it?
Right.
Yeah. So at 0, what can you say about the function?
Nothing.
Turning point.
It is a critical point, but we don't.
Critical point. And?
But we are not sure any other thing.
It is just a critical point, we can say. Nothing.
So from the what we have all now seen that it is just a critical point, right? But you can see from the graph that there is a turning at that function at that point, right? If you go closer and closer, you can see that there is a turning of this, right? So this is actually a turning point. So this is the minima for x power 4, right? But even at that point, the double derivative is 0. Got it? So that's why the double derivative test is inconclusive. Is it clear?
Okay.
Yes, now clear.
Okay. So double derivative is 0 does not imply anything. It can be
Sir,
maxima, it can be minima, it can be saddle.
Sir, if a function is if a function's derivative is increasing, can we conclude that the function is also increasing?
Function, if the derivative is greater than 0, then it is increasing. If it is less than 0, then it is decreasing. So if f dash x is greater than 0, then it is increasing. If it is less than 0, then it is decreasing. Okay? Clear?
Yes. The slope of tangent is.
Yeah, that is basically the slope of the tangent. Yeah.
The next problem.
Okay, so this is clear, right? Critical point, maxima, minima, global maxima, global minima, all this is clear, right?
Yes, sir.
Sir, can I say something?
Yeah, go ahead.
Yeah, like the for the point of inflection that you told, like f double dash x, whenever it's 0, we cannot conclude that it's minima, maxima, or anything. What I'm saying is, like for the double differentiation, if it is 0, then we need to calculate triple dash x. If that's not equal 0, then we can say that for the point.
But my point was it was not discussed in the lecture, right?
Okay.
In the lecture, it is only discussed till double derivative. So we should stick to that for now. Yeah, if you know that, then that is great.
Yeah, sir, I want to know that how will the graph of global maxima and global minima look? Like you just explained a few minutes earlier.
Yeah.
From this graph.
Yeah.
I want to know that how the graph for that global maxima and global minima we will see.
So suppose this graph, okay, can you see it? So what are the local maxima of this graph? So here we have a local maxima, here we have a local maxima, right? Is it clear?
Yes, sir.
Hello? Yeah.
Yes,
So
yes, sir.
which one is the
Hello.
So you are not audible.
So your voice isn't audible.
Hello, sir.
sorry, I got disconnected. Yeah. Let's go back. 1 minute. Yeah. Is my screen visible?
Yes, sir.
Yeah. So my point is, it is not necessary that local maxima or local minima is exactly global maxima and global minima. I mean, in this graph, you can see that this point is a local minima, but it is not global one, because there are some values of the function which is less than that value, right? So at this point, the function is taking its minimum value. So this one is the global minima.
But
Okay.
it's not a turning point, no?
So global minima does not necessarily it has to be a turning point.
Oh, okay, yes,
Okay.
yes.
So the turning point, so for turning point basically corresponded to local maxima or local minima, only for those, right? For global means the minimum value of the function. It may be the turning point, but it is not necessary that it has to be a turning point.
Okay, I got it.
For x square, the function x square.
Hmm.
Okay, so you know the function look like this parabola, right?
Yes,
So
sir.
this is the global minima as well as local minima, because this is a turning point and the function never goes below 0, right? It is always above 0. So 0 is the global minima and it is also a local minima. Okay.
Okay, sir. Yes, I got it.
Yeah. Okay. Okay. So yeah, this type of question was there in your quiz 1, maybe, right? So suppose a sequence is given and you have to find some other sequence depending on that one, right? This was one of the questions, right? So for a sequence of for a limit of a sequence, what you have to do, you have to take the value when n tends to infinity, right? When n go increasing, what is the value of the sequence tends to, that is the limiting value, right? So can you tell me what is the limit of the sequence an first? So an is Pn by Qn plus R.
P by Q. P by Q.
You need to divide by n and then P by Q plus R by n. So if n is infinity, R by n is 0. So P by Q.
N is not infinity.
I mean, if n is tending to infinity, value of R by n is tending towards 0.
Exactly.
So therefore,
an
P by
tends to
Q is
P by Q, right? Okay.
Yeah.
Then you have to find the limit of Bn. how we can find it? So this is q cube. So limit of bn is q cube, limit of an square plus q square, limit of an plus limit of this. This is independent of a. So this is so what is this? So limit of an square is basically limit of an into limit of an. So
pq square.
P square by q square plus this is p by q plus this. What is this limit?
Divide by
n.
S by n.
Is it?
No, is it?
It
It's
is
just
yes.
S.
Yes, only S.
Oh, only S. Oh, okay, okay.
S by 1 plus 0.
Changed.
So this is basically S by 1 plus 1 by n square, right? So this tending to zero. So this is only S. So what we get here? Q p square plus QP
PQ
plus
S.
Right?
Wow.
Yeah.
So this is the limit of Bn. Right?
Right.
So yeah, that's what you have to find here. So this was one of your quiz question. I
The
hope.
last question in the quiz.
Yeah, I hope.
No, Subhajit. In the quiz, it was completely different. I asked you in the last session, we have to differentiate. So this is what we were doing for all the session. But in the question, it was very different in the quiz. Suddenly we have to do differentiate.
One minute. That was another question. This was not that one.
Yeah.
This was the last question of the quiz.
This
Yes,
one
sir,
was
that was
the last
easier.
question. We had numerical values.
That was the first question, I think.
Differentiation was the first question.
Differentiation on the first question. So I will come
And
to
it
that.
was based on applications of derivative. And
Yeah, exactly. So yeah, I can do it.
everyone was confused because on the superficial level, it seemed like it's sequence and series like questions.
So suppose this kind of question was given, right? M by m square by 2 plus m square plus k square, like this. Something was like this, right? You have to find the maximum value when the sequence takes its maximum value, right?
So we
minimum
maximum minimum value, whatever that was given. So basically, when this is related with, so you can consider this function, right? Ax, it is x square by 2 plus
x square plus k square.
So x plus k. Okay. So this function you can consider. So if you consider this function, whenever you take the natural number, you will get the terms of this sequence, right?
So
now you know how to calculate the critical point of this x, this function.
Differentiation.
Right? You have to take differentiation, the first order derivative.
2x plus 1.
So 2x by 2 plus 1. Right? So here I have not given it calculated, so let's take this one.
Sorry. Yeah. Minus. So minus x minus 1.
So it is x minus 1. Okay. So when it is 0, so a dash x is 0 if
x equal to
1. Right? So x equal to 1 is your critical point. Right? So when x equal to 1, you have a critical point. That means, and what is that? Is that what is a double dash x? It is 1, right? So a double dash of 1 is also 1. So it is greater than 0. So it is a minima.
Local
minima. Yeah.
Local minima, right? So you know that this function has a local minima at x equal to 1. So the minimum value of the sequence, what will be the minimum value of the sequence? The minimum value of the sequence occurs at A1, right?
A1, yeah.
So the minimum value will be this. Okay? Clear? So basically minus half minus k.
Minus k.
So this
No,
is
sir. Here one question, sir.
Yeah.
So suppose after this differentiate and equate with 0, the value of x instead of integer we get a rational number.
In the question what we have given, it will always come as an integer. That was the point of that question. Otherwise you cannot conclude that.
No, in that case, can we approximate to the higher or lower limit?
No, you cannot do that. No.
Okay.
No.
So, Subhajit, one more doubt. So, when are
Is
we
it
going
clear?
to?
Is it clear?
Yeah, this is clear. But I want to know because in the sum it was not very direct that we have to apply the derivative. So, when should we do this kind of derivative thing? Because most of the time we are doing only n to infinity. We are checking only for the infinity or 0.
So when you do that n tend to infinity, when you are asking about finding the limit of that sequence, right?
Yes.
Only in that case you are taking n tending to infinity. But in that question, or when we are asking for some minimum value of the sequence or maximum value of the sequence, we are not asking about the limiting value, right? So those two are different. So in that case, you should not put n tending to infinity or calculate all this, right?
Because I was trying for n tends to infinity like that. Because when n tends to infinity, most of the problems we try, we get 0. So the hint is smallest number, minimum, maximum, right? In that case, we have to differentiate.
That is not necessary. I mean,
oh, it depends on the problem again.
Yeah, exactly.
Okay.
So,
Sir, some problem will you discuss with the sandwich principle, sir?
I will.
Sir, I have one query, sir.
Yeah, 1 minute. So let me conclude this first. So when we are asking about finding some maxima or minima, it's always you have to find the critical point, and then you have to check whether it is local maxima, local minima or not. If we are asking for global maximum, global minima, you have to do it accordingly, as we have seen that. Now we can relate those concepts with the sequence also, and sequence is a function. You know, sequence is a function from natural number to real number. Now the natural number is subset of real number, so we can take that as some variable x, and we can conclude that. And in that case, we have to do this local maxima minima checking. Okay, is it clear?
Yes, sir.
Yeah.
So some sandwich principle, sir.
I will come to that. Yeah. Now, someone was
actually I am confused. Always have a confusion between this bounded function and this sandwich principles.
I will come to that. Yeah. And someone else also was asking the question, right?
So,
yeah.
Sorry to ask I mean, you already discussed this, but finding, if we are told like to find local maxima or minima on closed interval, there was a video there was a part in the lecture where the professor found the local maxima or minima in closed interval.
Yeah.
And like you said, we find
yeah.
Like you said, we find global maxima and minima in intervals, not the local ones.
No.
So
we can. Okay, 1 minute. 1 minute. So I think there is a confusion. You suppose I am asking you to find the local maxima, local minima in some interval AB. Okay.
Yeah.
In that case, what you have to do? You have to check for those points C where the function is not differentiable and
0.
F dash C is 0, right? And this C should be in open interval AB. Okay, you don't have to consider the endpoints. Okay. So for local, when you are checking for local maxima, local minima in some interval, some closed interval, then also you should ignore the endpoint.
Okay, so it's just to make sure that the points lie in that interval.
Exactly.
Okay, now
But when I am asking for global, you have to include those points.
Okay, yeah.
Okay, got it?
Yes, sir.
Even in the problem, the interval is given as an open interval. Then also for calculating the global, we will consider that point.
No, if it is open interval, then obviously these 2 points are not in the domain. Why should we consider that?
Sir, I have a small query.
Yeah.
Regarding that sequence, sir. So a sequence is also a function. That's okay. From natural numbers to real numbers.
Exactly.
So then, what is the difference between a function fx equal to x and a sequence n?
Yeah.
How they differ?
So suppose I have this function fx equal to x, and I have this function fx equal to x. Is there any difference?
Yes, or are they the same? Because when we will say fx equal to x, it will be a straight line.
Yeah. So can you get suppose in this function, okay, in the second one, can you get 1.5 as an image?
No, here in the sequence we won't be getting.
We won't get. But can we get 1.5 as image?
Yes, here we will be getting.
So can you see the difference between these two functions?
Yes, but otherwise they are the same.
No, they are not the same. They are only same on the natural numbers.
Okay.
Okay, they are only same on the
When they
natural
are natural number, their behavior will be the same.
same. But otherwise, these two are different
Yes.
because
That
their
is the
domains are
difference.
different, right?
Yes. Yes.
Their domains are different. Here, the inputs are we are taking from the natural number only, but here we can take the inputs from any real number. Okay. Okay. Yeah. Huh. So one more doubt was there for sandwich principle, right? Okay. So and bounded and unbounded function. So what is bounded function? Can someone tell me what is bounded function?
Bounded function means the function is restricted between two values. Range of the
Sin x cos x is example of bounded function. You want the definition.
range of the function is restricted within two values.
Aditya, give someone else to say also. Yeah.
When we have the greatest lower bound and least upper bound
What
defined.
does it mean by greatest lower bound and least upper bound?
Least upper bound means suppose any given value, okay. Above that value also the function must be less than, but above among those values whichever value is the least and the function is less than that, that's called the least upper bound. And similarly for the greatest lower bound, like there could be many values, there can be many values from which the function might be increasing, okay. But that one value among all those lower bound values, just after that the function starts increasing, that's called the greatest lower bound. I hope it's clear.
Yeah, I mean you don't have to complicate this for the bounded function only. I mean suppose fx, I am taking fx. If there are some number m and m, small m and capital M, such that this fx always lies between these two numbers. Okay, so greatest lower bound and greatest least upper bound, those are some defined concept in view of analysis, mathematical analysis. But if we get some two numbers, small m and capital M, by which we can bound the value of the function, then we can say this function is bounded. For the definition of bounded function, this is enough. Okay.
Yeah, yes.
This m and capital M, small m and capital M, may or may not be greatest lower bound or least upper bound. Okay, they may or may not be. That means suppose I have cos x. Okay, I can say that cos x is bounded between -2 and +2. That I can say, right? But this -2 and +2 is not greatest lower bound and least upper bound, right? -1 is the least upper bound. Sorry, 1 is the least upper bound and -1 is the greatest lower bound, right? But we can say that it is also bounded between -2 and 2. That we can say anyway, right? So this function, when we are finding some small m and capital M, such that the functional value lies between those two, that is basically the bounded function. Okay. So for bounded function, we must have both this property, both this least lower bound and upper bound, both this has to occur. Suppose for e power x, right? Is it bounded?
No.
No. But it has a lower bound, right?
Yes.
Because 0 is always less than equal to that, right? I mean, you can say strict. But there is no upper bound. We cannot bound it by some capital N. There does not exist such term, right? So this function has a lower bound, but it is not bounded function. Okay. For bounded means we must have both lower and upper bound. Is it clear?
The bound thing is basically the highest value and the lowest value of a particular function, right?
That does not necessarily that it occurs. I mean, it takes that highest value and lowest value. I mean, e power s does not take 0 as a value, right?
No.
But it is bounded by that.
Bounded by that. Yeah.
It does not necessarily that the function has to take that value. Okay, that's my point. That's why I don't want to go through a definition of greatest upper bound, greatest lower bound, and least upper bound. So that is
the bounding values will be fixed in that case, no?
Huh?
Bounding values will be fixed for that cases.
Which cases?
Like here for e to the power x, 0 is a lower bounding value. Below that it cannot go. So that's a fixed value.
No, I can say this one also, right? I can say -1 is less than e power x. That is also true. And minus 1 is also a bound.
Okay.
Yeah.
So bounding value may change.
There should exist some value that does not necessarily it is fixed. But when we are talking about greatest, that what someone is also telling that least upper bound and greatest lower bound, those two are fixed. But it is not necessary to conclude for a bounded function. You have to find those values exactly. You don't have to go to that far. Okay.
Okay, sir.
Okay, sir. It's a sandwich principle, sir.
So I am coming to that. So can you give me an example of bounded function other than this sine and cos?
-1 to the power n.
So what are the bounds?
1 and -1.
-1 plus 1.
So -1 and plus 1. Okay.
1 by n.
1 by n. Okay. Is it bounded?
Yeah.
Yeah. So what is the upper bound and lower bound?
0
1
and
and
1.
-1.
0 and 1. So this is one bound. So observe that this function does not take the value 0 anywhere. Okay. It takes the value 1, but it does not take the value 0, but it is bounded by 0.
Yeah.
Okay. Yeah. Okay. So these are some. These are basically you are giving some sequences which are bounded and unbounded. Similarly, 1 by x you can take, that is a function from real to real, which is bounded between 0 and 1.
Yeah. If n is integer, you are taking, na?
But even you can take any.
No, like number. 1 by n, then it will be, if n is positive, then 1 by n will be, won't be a bounded, like it will be 0 will be bounded.
So that's my question. Can I say this for any real number?
No.
No, right?
No.
Because I can get negative values also, right?
Yes.
Yeah.
Even if positive, then also it won't be like.
It won't be 1. It may not be less than 1, right? Because I can take half. X equal to half, then it will give me 2. So this is not true, right?
Natural.
So for sequence 1 by n, this is bounded. But for function 1 by x, where x belongs to real number, it is not bounded function. Okay. Is it clear?
Yes.
Yes, sir.
Yes.
Okay. So now the sandwich principle, what does it say? Suppose I have a sequence. So let me explain it by sequence first. I have a sequence an, and I can take two other sequences or two other distance bn and cn, where an each for all n. This is true for each n, maybe. For each n, an is bounded between cn and bn, these two numbers. So if I get this, then if I know the limit of bn and the limit of cn, and if those two are equal, then suppose this is equal to L, then I can conclude that limit of an is also L. Is it okay?
Yes, sir. This definition is okay. Actually, sir, facing where the problem in the problem it will given an. Okay. And since I am unable to calculate the limiting value of an, so I am trying to take a help with the bn boundary and cn boundary. But
so you have to,
bn and cn, there is a sequence that deriving of that sequence is difficult, sir.
I mean, that has to come from your intuition. There is no way to find bn and cn.
Will you take a problem from quiz? I think it was there.
Which one?
Yeah.
Sandwich. There was one problem, I think. Can you take one problem?
Yeah, so in quiz, was there a problem for sandwich?
Quiz 1, I think.
No, there was no problem.
In the first mock test, there was a
one
problem.
in combining with limits, sandwich principle.
Yes.
Can you tell me that problem? I forgot that.
Yeah, I will just 1 second.
Yeah.
So are you going to discuss linear approximation?
Okay. Linear approximation. Okay, I will do that.
There's a question in the mock test.
Yeah, I will do that. Yeah, sure. I'll do that.
It's question number 4, I think.
Can you tell me the problem?
Yeah, f of t is equal to 1t square sine 1 by 1t plus b.
Okay, t square.
T square sine 1 by 1t. 1 by 1t. 1 upon 1t.
Sine. It is inside sine.
Yeah, inside sine. Yeah, inside sine.
Okay.
1 by t.
1 by t. Okay, okay.
And then plus b, b constant, plus b. If t is not equal to 0. And the function ft is 1 if t is equal to 0.
If t equal to 0. Okay. So you have to check whether it is continuous or not, right? You have to find the d value of d first, then you have to calculate some other thing, right?
Yeah, just to arrive at b value, we have used the sandwich principle, I think.
Okay. Yeah.
What's the exact question, sir? What we need to find?
So you have to find d if it is given that t is f is continuous. So
Okay.
if f is continuous, then find the value of d. Find the value of d. This is the first part of the question. Yeah. So what is the sandwich principle can you use here? How can we use sandwich principle? So we want to find the limit t tending to 0 ft, right? Right?
Yes. Sir.
Yes.
So basically, I want to find the limit t tending to 0 t square sine 1 by t plus d, right? So basically, let's try to find this limit first, because this is independent of t anyway. So if I just find limit of this one, so if I just find limit of t square sine 1 by t, and this d I can put outside. So if I can find this, then it is enough. Now sine, any sine function is bounded between -1 to 1, right?
Yes.
Now there is t square sine t. Now t square is always positive, right? So if I multiply with t square, the inequality will not change, right? I can write this, right? Now this function in the middle is bounded by t square and minus t square, right? Now if I take the limit t tending to 0, this is minus t square, this is t square sine 1 by t, which we want to find, and this is limit of t square, right? T tending to 0. So what is this limit? This left hand side limit? This is
0.
0. And what is this limit? The right hand side? Again it is 0,
right hand side is 0.
So basically, the limit of these both left and right is 0. So the limit of the middle one is also 0. Is it clear?
Yes, sir.
Okay.
So that's how we can use Sandwich theorem.
So d equals 1.
So yeah, d equals 1, right? Exactly.
The other way to find this was LHL equals RHL kind of thing.
I mean,
LHL.
that's what we are doing. I mean, the LHL, I mean, left hand side limit and right hand side limit will always be same, because for t not equal to 0, I mean, when t is positive and t is negative, the function is the same, right?
And then
only at 0 it is different, right?
Yeah.
So left hand side and right hand side limit is always, in this case, will be same because the function is same. So we only have to calculate what is the value of that limit when t tending to 0.
Can you explain this again, like this this portion, like the sandwich portion, like again, please?
1 minute. So when t tending to 0, the left hand side and right hand side limit is same because the function is the same, defined in the same way, right? So I want to find the t tending to 0 ft, and that I have calculated. This is 0 plus d, that is d. Now I know this is d, and what is f0? If it is continuous, then it should be equal to f0. f0 is 1. That means d should be 1. Okay. Okay. Now for the sandwich, again, the sine function, that is always bounded between -1 and 1, right?
Yes.
Now t square is greater than 0 always, right? T square is positive for any value of t. So if I take the multiplication with t square, then the inequality will remain the same.
How you thought it is sandwich? Like you thought like directly we can't take limit, so that's why we used, or like sine 1 by t is bounded function. From that you got the idea. How
What is your question? I am not getting your question.
How you got that idea that question has to be solved with sandwich?
Because our first approach would be to equate the limits, like LHL equals to f of t at 0. That we would do.
Exactly. Now, yeah. So your first thought came that you have to equate the LHL and RHL, right?
LHL, RHL at
equal to value. Yeah.
Okay, 1 minute. So LHL and RHL should be equal. The first thought that came to your mind. Now, what is when we are approaching from the left hand side of 0? What is the functional value? What is the function defined there? This is t square sine 1 by t plus d. When I am approaching from the right side, that is the same function, right?
Yeah.
So both of them must be equal, right?
Yeah, and both of them must be equal to 1 also.
Both of them must be equal to 1 also. So what I need to calculate now? I need to calculate what is the limiting value of ft, right? When t tending to 0. That I have to calculate, right?
Yes.
So I have to calculate t tending to 0 ft. This one I have to calculate.
Or any one thing also, na sir, like any, like if only if LHL also, or only if RHL also.
I mean, that's my point here. LHL and RHL are same.
Yeah.
So I can just calculate t tending to 0.
Okay. Yeah.
Because when LHL and RHL are same, that is basically t tending to I mean that limit exists, right? And that is the limit at that point, right?
And
that was the definition.
And for selecting the problem, we have to just figure out which one we can set the boundaries for first.
So okay, let me come one step by one step. So we have to find the limit at t tending to 0, right? At this point, it is clear till this point.
Yes.
Okay. Then what I have seen that this is a trigonometric function is involved here, that is sine 1 by t, and I have to calculate t tending to 0. Now we know that this is the first part. The second part is just plus d, so this is independent of t. I can take that outside. So I want to calculate only t square sine 1 by t, the limit of that, right?
Yes.
Okay. So I have this function t square into sine 1 by t. Now I know this is product of two functions. There is some sine function and there is some polynomial type function, right? Now I know this sine function. Now I want to calculate the limit of t square sine 1 by t. Now I can see that there is no formula which is given which I can apply directly. So let us try. We know one thing, that this sine function is always bounded between -1 and 1, right? So this t square sine 1 by t is bounded between minus t square and plus t square. That we know. Now we know that if we apply Sandwich theorem here, we can get the limit to be 0. Is it clear?
Okay. Yes.
Yes, sir.
Yeah. But yeah, I mean, I cannot teach you all the intuitions because some intuition has to be come from your side. I think there is no way to.
That's come from practice, sir.
Yeah, exactly.
That means first we need to apply a limit. If we are not able to find or just guess what we can apply for limit, then we can just go for the Sandwich theorem.
Yeah, exactly. So you know some special type of function for which you know the limits, right? If you see that those type of functions are appearing, then okay, go ahead and apply that. If you are finding that okay, nothing such can be applied. So basically Sandwich theorem can be applied when some trigonometric function is involved or when some -1 power something is involved. In those cases, this Sandwich theorem can be applied.
Okay, so this is Sandwich theorem.
If we can generalize, so basically, if the limit is not directly known, we apply all the limit axioms, right? Limit a plus b is a plus b at 1 by 1, and sandwich comes at the end.
Yeah.
Okay.
Can you please cover g of f of x problems? G of f of x kind of problems that was there in quiz.
Okay.
Yeah.
And also, sir, one more question: that area.
Like limit is also a little tough.
So
approximation, linear approximation.
Yeah. I will linear approximation. So
yes, sir.
Linear approximation first, then I will come to that. So linear approximation at some point x equal to a. If I want to approximate the function fx by a linear function at some point fx at x equal to a, what I have to do? I have to calculate the derivative first. Okay, what is f dash x? And I have to calculate the derivative at that point. So I have to calculate f dash a, and the linear approximation, that is lf at a, will be f dash a into x minus a plus fa. Basically, this is nothing but the tangent at that point. That is the linear approximation. Okay. So when you are given a function, you just have to calculate f dash at that point. Take the multiplication with x minus a, and you have to also find the functional value at that point, and you have to add that up. Okay. So that
This is y equals to mx plus c.
exactly.
Equation.
So your slope is basically same as the slope at that point of the function, and this is your y-intercept, right? Not this is basically when fa plus f dash a into a, that is your y-intercept. Okay, so this is the formula for linear approximation. I think it is discussed in the lecture also, right? In one lecture is completely dedicated to that. So when you have given some function, you have to calculate all this and you will get the linear approximation.
Yeah, but Subhajit, in quiz it was very different. That's why I asked you to explain. Not the concept is fine. Yeah. Yeah, there the linear approximation is given, and we are asked to find in the reverse way. But still, it is a little confusing because of the function.
So can you tell me the function?
Yes, f of t is equal to 4t square sine 14 by minus 10t inside the bracket.
Sine
14 by minus 10t.
Okay, yeah.
Plus b.
Plus
bracket.
B, okay.
Yeah, b is outside. If t not equal to 0.
So this is the part
minus,
of the,
yeah, minus 5 if t equal to 0.
Okay. So from the previous thing, we can calculate that if ft is continuous, then I can calculate b, right?
Yeah, yeah.
What will be b?
Yeah, the expression is given as for the best linear approximation of f of t at t equal to n. They have given the linear approximation.
Okay, okay.
So from
I will come to that. I will come to that.
But to find the b, we can use the sandwich principle again.
That is the previous problem. So what is b? If it is continuous, what is the value of b?
Minus 5.
Minus 5, yeah.
Yeah. So I got the function completely. So this is my function. Sorry, this is minus 5. If t not equal to 0. Now at what point I have to calculate the linear approximation?
T equal to 1.
T equal to 1. So t equal to 1 means the function is the first one, right? This one. Right?
Yes.
Oh. So what is f dash t? At first calculate this. So it is 8t sine 14 by minus 10t. Then what is that? 4t square cos of 14 by minus 10t. And this 14 by minus 10 will come outside. 14 by minus 10 will come outside. And if I have to divide this, this is 1 by t square, right? So sine by t square will come, right? Is it clear?
u dash plus half plus.
Minus won't be there.
Minus will be there.
Minus 4 why you are doing like this?
Anyway, it is given in the problem. So we can check. We just have to, only the coefficient we have to understand.
So this is minus 14 by 10t, no? So minus 1 by this should be plus. This is right? This is 14 by 10. I am deleting the minus from here. Okay.
Then it's
yeah. Okay. So what is this? This is
no. Why it is plus, sir? It is minus.
The formula is u dash v plus v u dash.
So
and
if it is,
this is 1 by t.
Minus sign outside, no?
I mean, this is composition function, right? This is composition function. I have to derivative
t to the power minus 1. That minus 1. Yes, yes.
That is coming also, right?
There one more minus will be there, na? Minus 1 by t square it will be.
Like, exactly. So yeah, if there is some mistake in calculation, you will just figure it out. So
yeah, only the method. The initial part was difficult. Now it's okay, fine. Yeah.
I mean,
we didn't know the B. No, the B type sandwich. That is where That's where we all, yeah.
Okay.
Now
So
it's
now
fine.
you have to just calculate the value of f-1, value of f1, and put in the formula, then you can find the coefficient.
Yeah, because of the b value, it is just we are stuck. That's what. Yeah, yeah.
So it is okay, right? So
Yeah,
this
it's
problem
fine.
is also not difficult in the quiz, right? So we have find 4 problems in the quiz which are not difficult. Right? Is it clear?
Can't we say they're like that? T square into fluctuating value between -1 to 1. T square will
Huh?
T square into fluctuating.
Someone's
Please tell them to mute their mic.
yeah, who is that? I am not figuring out. Yeah, who is
It's Aram.
Aram, can you
Sorry.
yeah. Okay, yeah.
I was saying that can't we directly say it like for that t square into that, like t square into sine of something, okay, and like sine of 1 upon t is that it will be that positive infinity or minus infinity, let it be, means if t, so it will be any value between -1 to 1, okay.
That is the Sandwich principle, no?
And t square will means fluctuating value between -1 to 1, and t square will tends to 0. So automatically the whole value
That is the Sandwich principle, what you are saying. That is exactly the Sandwich principle.
Okay.
Okay.
I use that thing directly.
Yeah. That is the Sandwich principle going behind all this. Yeah. Okay, so it is clear, right? Linear approximation.
Yes, sir.
Yeah, and someone was asking about someone was asking about Riemann sum in the quiz problem, right?
Yes, sir. Especially capital.
So I have started today's discussion with trapezoidal sum. Were you present there?
No, sir, I was not present.
So you just go back and see. I mean, that is not difficult at all. I mean, if you know the formula for trapezoidal Riemann sum, then it's clear.
Sir, can you give one example of that maximum volume? How can we go for it? Like the question that came in quiz.
So yeah, so volume can be, so there are some relation between R and X, right? The radius and the X it was given, right? So you can write it in terms of a X. So you can write the volume as a function of X. Now you find the critical point of that function.
Okay.
And check whether it is maximum or minimum. So you will see that it will come as maximum. So if you will get the maximum volume.
Okay, so my question is that we have to find or differentiate it with respect to the X or the M. Like I was got
any
little
one of
confused.
that you can differentiate with respect to any one of that. I mean, transform the whole function either with respect to X or with respect to H, any one of that. So depending on the variable, you have to do the differentiation and you have to find the critical point. Okay.
Depending on what we have to prove.
Yeah.
Depending on what we have to prove, we have to change likewise.
Yeah, exactly.
So the composite function example, fx and gx1.
So okay. That was really an easy problem. So can you tell me one problem on that?
It was, I exactly don't know. So wait a second.
It's the same from quiz 1.
Yeah, or we can take like that one. X upon X plus A. Voila.
So I think the problem in the quiz was f of some, suppose
fx equals to some function of g into some function of h.
Like this, right?
Yeah, it was actually g of 5x square plus 2x.
So this KLM will vary for all of you, right?
Yeah.
So this kind of function was given, right?
We had to find hx by h dash x by hx.
It's just 0 by 0, right? H dash 0 by h 0, right? This one you have to find. Okay. So what is h dash x? Can you tell me? This is f into g, but all of these are composite function. There are function inside that also, right? Right?
F into g dash plus g into f dash.
Okay, one minute. This pen is creating some problem now.
Sir, will you give a session tomorrow?
No, today is the last session. Okay, so what is this function? So we have to differentiate this also. So this is 3kx square plus L, right?
Yes, sir.
Into f dash
of
is kx cube plus Lx into G. This is the first term. Then second term is basically you have to
as it is
take this differentiation. So 2mx plus n f kx cube plus Lx into G dash
mx square plus
mx square plus nx, right?
Yes, sir.
Yes.
So what is h of 0? H of 0 is, so
L
here if you
times
put 0, this is L,
F
f
dash
dash 0, G0 plus n
times
f of 0, Z dash 0, right?
Yeah.
It's h of 0 or h
H
dash?
dash 0, H dash 0. Okay?
Yeah.
Now what is H0? H0 is f of 0 into G of 0, right? Okay?
Yeah.
Yeah.
So can you divide this now?
Oh, yeah.
So what we will get? F dash 0, G0 by F0, Z0 plus n F0, Z dash 0 by F0, G0, right? So this is G0 will cancel out, as this was given that G0 is not 0. So we can cancel that out. So this one. Okay?
Yes, sir.
Is it clear?
Yeah.
And it was given that these both are equal, I guess.
Equal or
not
some
equal.
value was given, so it is. Right?
Yeah.
So again, this problem should have taken 2 or 3 minutes to solve. Right? So we have solved 5 problems of quiz today.
Yeah, the problem started when we h of 0, when we calculated h of 0, it was 0 and we thought it would be infinity or something.
No. You have to take care of the composite function, which was inside that.
I did not write f dash and g dash that time. That was
Yeah. So yeah, actually the problems in the quiz was not difficult, but I think the approaches you have taken may be creating problem. Right?
No, I have a kind request.
In a slow manner.
One by one. Yeah, Meena.
So you explain the derivative this s dash x in a slow manner, like how we got this.
Okay, so suppose I have a function. Suppose again. Yeah. So hx is equal to, suppose f of x square. Okay. Suppose start with this small function. What is h dash x? Can you tell me what is h dash x? Meena?
Sir, f dash of x square into derivative of x square.
Exactly. Right? Okay. And suppose I have hx fx gx. What is h dash x?
Derivative of fx into gx plus derivative of gx into fx.
Exactly. So this, right? Okay. Now what we have here? Here we have f. In between there is some function x cube plus lx into g, suppose mx square plus n, like that, something like that. Okay. Okay. So what is h dash x now? So this is first product of two functions, right?
Okay.
And inside f there is some function. So at first I have to write f dash this x cube lx into g of mx square plus n, right?
Yes, sir.
This pen is creating much problem now. Okay. So, and this f dash part, I have to differentiate the function which is inside that, right? As we have done in case of x square, right?
Okay.
So
With
I
the
have to
chain
put
rule.
them. Yeah. So this is 3x square plus l, right?
Okay.
Similarly, for the second one, so f kx cube plus lx into g mx square plus n, and I have to take this derivative of this one also, m square plus n, So it is 2mx plus, suppose this is nx. So n, right?
Okay, fine, sir. Actually, I was taking f and g as some other constant, some other
No.
functions itself.
Okay, this is basically the, I mean, combination of these two type of thing.
Chain and product rule.
Chain and yeah.
Sir, but in this question, it is given that g dash of 0 is equal to g of 0. So do we need to solve all this?
Yeah, otherwise how can you do that?
Because then directly if g dash of 0 is equal to g0 and a dash of 0 is equal to h0, then f dash of 0 will be directly twice g0 h0.
Why?
Because the values are equal.
No. I mean, you can see now there is some constant coming outside. These functions are coming outside. You have to put 0 in that. This is not just f dash x into gx and f into g dash x. This is not that function.
Directly you.
I mean, this is not just f into g. There is some composition. There is some function inside f and inside g.
Yes.
Right? Yes. Have you got it?
Yes,
if it is just hx equal to fx gx, then you can do that.
Yes. I haven't solved it and I directly
many of you have
I
done
rushed
that.
To it.
Yeah, many of you have done that. Yeah, that is a great mistake, I think. Okay, this is a chain function along with composition function.
Okay.
So you have to apply these two rules here. Okay. Yeah. So
now can you discuss that some portion of week 7 and 8? Like
week 7 and 8 has been discussed yesterday also, right?
Like actually the portion you left, that the portion you left, that portion was not discussed. Continued that portion, like the spanning set and that one, like
that is discussed yesterday, no?
No, actually that was told that like it wasn't like he discussed in just 1-2 minutes, like.
Okay. What is your doubt there?
Could you just the column space, row space, I want to know.
So watch last 2 weeks session.
And one more thing, the minimum spanning set and that.
Then watch Thursday session of last week. Okay, I have already discussed all this. So more or less I have covered everything in these live sessions. Okay, so if you go back to the session and you can see that those are discussed already.
Okay, sir.
Yeah.
Sir, in the sir mock test, that mock. Hello.
Yeah.
In the mock the quiz. So one problem in second mock, sir, the vector problem. There.
Are you trying to say something? I mean, your voice is breaking and we cannot hear you anything.
Can you able to hear me?
Yeah, Sumit, I can hear you, but Ashutosh.
No, it's Ashutosh's voice.
Yeah, so Ashutosh, can you?
Question 7. What is the dimension of that matrix?
I cannot hear you properly, Ashutosh. What you are saying? Okay, Shamit, go ahead.
Sir, one problem in the mock quiz. So one vector problem is given. Only first 2 properties given. They're closer with addition and closer with multiplication. And also from the
those are not properties. I mean, that's how the
necessary
multiplication and that's the addition and scalar multiplication which has to be defined in that vector space. That is given there.
Yes, to be a vector space, that is required thing.
No, that is how we are defining the addition and scalar multiplication. When you are talking about some vector space, you have to give me some addition and scalar multiplication, right? That is the definition of the vector space. You have to define some addition and scalar multiplication. That is given here.
If the addition and the multiplication is not proven there, then we can't call that as a vector space.
I mean, for a vector space, you have to define addition and scalar multiplication, right?
Yes, sir. My confusion is that, sir, these two are given in that vector space, but also from the necessary condition is given x00 such that x belongs to our union 0 y0 belongs.
That is the set.
So from that set, I can see the 0 is also there.
Okay.
So still that cannot be why the answer.
There is 8 axiom for vector space. You have to
That
right?
yes. I am some coming that if that all these 8 in type of this type of question, if all that 8 condition is not given, then we directly eliminate that condition.
Not given, when you have to check that. 1 minute. So I have given a set S. I have given one addition. What is the addition in this set? I have defined what is the scalar multiplication in this set, right?
Yes.
Now you have to, I ask that whether this is along with this addition and scalar multiplication, is it forming a vector space or not? So you have to check all the 8 conditions to see that whether this all together form a vector space or not. Is it clear?
Oh, actually, sir, that is there, but we only check first 3 conditions: addition, multiplication, and then 0
Addition
is there or
not
not.
a condition.
It's not a condition, right? It is under definition.
But
what
are the conditions? What are the conditions you have to check?
Addition?
No, addition is not.
Oh, sorry, associativity.
Before that?
Commutative.
Before that?
0.
Check whether this addition is closed or not. Right?
Closure
property.
Closure
First,
property.
you have to check closure for both of these.
Yes.
Then you have to check commutativity. Addition is commutative or not. Then you have to check associativity. Right? Then you have to check whether there is 0 or not. Okay? Then you have to check additive inverse or not. Is there exists additive inverse?
Yes.
Right? Then you have to check distributive property of scalar multiplication. There are 2. Right? There are 2 distributive properties. If you check all this, then you can say that it is a vector space or not. And one thing is more there, 1 into V could be V. Okay, so these 8 properties you have to check. Okay, then you can conclude that it is a vector space or not. Is it clear?
Yeah, okay.
But Subhajit, for every given vector, do we have to go through 8 axioms? It is enough only those 3, right? Vector addition, scalar multiplication, and 0.
Actually, sir, I thought ki if the addition and multiplication just means closure property is there, then rest.
1 minute. Suppose I am giving you R2, okay? R2 means the set is XY such that XY belongs to R. Right? Suppose I am defining addition like this. So this is given. Addition, how we are defining addition? This is given. So X1, Y1 and X2, Y2. So these 2 are given. How I am defining it? Suppose I am defining it X1 plus X2, comma 0. Okay? And multiplication I am defining like this. X1, Y1 is basically CX1, CY1. Okay? So these are addition. This is how I am defining addition. This is how I am defining scalar multiplication. Now I am asking whether this set is a vector space or not. What should we check first?
Yeah, addition, which doesn't actually
not a property. This is addition. You have to check whether addition is closed under this addition or not, right?
Yes. So this doesn't. This is not closed under addition.
Yeah. Why?
Because we have 0 at that point. We should have Y1 plus Y2, right?
No. I mean, what should have? There can be defined addition also, right?
Yes.
So
here we cannot get anything, comma 1.
So closed means it has to be inside the set. It is inside the set, right? It is in R2. This vector is in R2, right?
Yes.
So it is closed. Right? Closed means if you take 2 vectors from R2, the third vector, I mean after the addition what you get, that should be inside R2. Yes, this is inside R2. So closure is there. Closure for both addition and scalar multiplication is there. So first property is satisfied. Okay?
Yeah.
Is it clear?
So for 1, 1, and 1, 2, it will be only 3, na? Sorry, 2, 0. 2, 0. We have to exclude Y1, Y2.
So that is also an addition. Yeah, that's true. That's fine. Okay.
Yes.
Now my second question is it commutative? So you see that what you have to check? You have to check all these properties. Otherwise, you cannot tell whether it is vector space or not. Okay. So closure thing does not guarantee that it is a vector space.
So with this closure means whether the point 1 is I am getting or not, this I don't need to check.
No. That is not closure. Closure means, so addition means what? Addition means this is an operation from R2 cross R2 to R2. I mean from V cross V to V, right? So basically what you get here, is it inside R2 or not? Okay, that you have to check.
Okay, that means all R2 to R2, whether I am getting or not, that doesn't matter anything. Whether the point I am getting, whether it is in R2.
If you are getting the whole R2 or not, that does not matter here.
Oh,
okay? It should be inside the set you have given.
Okay.
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 Is
and
it
sir,
clear?
Yes, now it is clear. So if the first two property is satisfied, then rest of the thing extended one.
No, why? This is not the extent. This is not the usual addition. You can see that. So there can be some difference 0. Right? So this is closure is clear, right?
Yes.
Okay. Is it commutative? The addition? It is commutative, right?
Yes.
Okay. Is it associative?
Yes, sir.
It is associative, right? Okay.
Yes.
Now, is there any 0?
Yes.
Yes,
there is 0. Okay. So 0 means what? 0 means V plus 0 should be V for all V, right?
Yes.
Okay. So suppose I am taking 1, 1. Okay. What is my 0 here? So that I can get back 1, 1. Is there any vector so that I can do the addition and get 1, 1 back?
0.
No, here 0.
No.
So if I add 1, 1 and 2, 0, what I will get?
3, 0.
Why 2, 0? I mean, where from that came? 2, 0. What is this addition? 1, 1, 1 plus 2, 0?
3, 1.
3, 1.
Is it 3, 1? Yeah,
No,
addition
3, 0. 3, 0. It should be 3, 0.
Someone please stop your mic. Yeah, so what is this? 1, 1 plus 2, 0. What is this?
3, 1, sir.
3, 0.
Oh, okay. From the definition. Yeah.
So now this is my addition. This is not the usual addition. Okay, I have defined an addition here, and I have given you to check whether this addition is forming a vector space or not. Okay.
Yes.
So this is 3, 0. So clearly this is not the case. Is there any 0? Is there any 0 vector in this? So 0 vector means I have to add something x2, y2, so that I can get back this 1, 1. Is there any possibility of x2, y2? Can there exist?
0, 0? No.
Not possible.
0.
Okay, what happened is 0, 0. This is
1,
0. So I am not getting back 1, 1.
1 equal to 0.
It is not possible, sir.
So it is not possible to exist because the second coordinate will always be 0. So here the problem arises in this point. There is no 0 vector. Okay. Although the first 3 properties are satisfied, problem arises at the 4th point. The 4th axiom is not.
Can you please re-explain this a bit? Only this thing, the 4th one. Yeah. So can you re-explain the 4th one? I just got lost.
Exactly. So for 0, if there has to be a 0 in a vector space, what we have to check? For any vector, I have to find some vector such that if I add it to that any vector, I will get back the same vector, right? So if there has to be 0, suppose I am taking any vector, that is I am taking 1, 1. Is there exist any vector x2, y2 such that when I add these two, can I get 1, 1 back? That is my question. Can I get 1, 1 back?
If I write 0, 1, then sir?
Then what happens?
Still it
1,
will
1 plus 0, 1. What happens?
1, 0.
Then again 1, 0.
No
right?
addition can give 0.
Because the second coordinate is always 0, whatever you have put in that place, right? So I can never get back the same vector.
Like, so you mean to say that 0 vector is not necessarily mean 0, 0, 0? Like,
yeah, that depends on addition. Okay, for usual scalar addition, coordinate wise addition, and usual scalar multiplication, that is the 0 vector 0, 0. But here I have changed the addition. I have defined the addition in some other way. Okay, which is closed under this, closed under addition, commutative, associative. But the problem is there cannot exist any 0, because if there exists some 0, then I should get back the original vector after adding to that. But it is not possible, because whenever I am doing some addition, the second coordinate is always becoming 0. So if I take some vector where the second coordinate is non-zero, I am not getting back the same vector. Okay, is it clear now?
Yes, sir.
Yes.
Yes, clear.
So okay, so now you have understood what you have to check when I am giving you some set and addition and scalar multiplication. What you have to check? You have to verify all these axioms. Okay.
Yes. Okay.
Sir, I have another doubt.
Okay.
Regarding the matrix, dimension of the matrix. For a 2 cross 2 symmetric matrix, what will be the dimension of it?
So Ashutosh, where you are present in the earlier live sessions also, right?
Actually, this problem I forgot to ask.
But I have discussed that. That is the point. Okay, for symmetric I will say you. Symmetric I will say what is the dimension. Okay. So suppose I am taking 2 cross 2 symmetric matrix. Symmetric matrix means, suppose I have this thing, then symmetric means A11 should be equal to A21, right? Is it clear? Because in that case, that A equal to A transpose, right? A equal to A
Here
transpose.
A12 na the condition A12.
A12, sorry. A12, right?
Yes.
So the matrix here, if we can write it like this: A11, A12. This is again A12, A22, right?
Here by forming the basis, I could find the dimension of it is 3.
Exactly.
But if we introduce row echelon form,
that is different. That is the rank of some matrix. That there are some different concepts. This is the dimension as a vector space. This is the dimension of the vector space. So this vector space consists of all the elements where the elements are symmetric matrices. But the rank of a matrix, that is for a particular matrix you are considering the rank. Okay, these two are different. Don't confuse these two.
I mean, rank of a matrix and dimension of the matrix is different.
This is not dimension of a matrix. This is dimension of the vector space consisting of those matrices. Okay. Suppose I am taking. Suppose I am taking R2. Okay. R2. So R2, any vector of this R2 is of the form. Can you tell me what is the form of the vectors in R2? Hello?
0, 0, 1.
0,
0, 1. 0, 1, 1, 0.
I mean, any vector is of the form x, y, right?
Oh, yeah.
Okay. Okay. So, suppose I am taking 1, 2. Okay. So, you know what is the dimension of R2?
2,
right? Okay. Now I am taking one vector in R2, that is 1, 2. So this I can treat as a matrix, right? As a row matrix, right?
Yes.
Okay. Now what is the rank of this matrix?
1.
Rank of this matrix is, suppose this is my A. So rank of A is 1. So see, this is the term. this is a vector in that space. So rank of this matrix is 1, but this is the dimension of the space. So all the elements of this space are basically this kind of vectors. So similarly, when I am talking about symmetric matrix, so this is the space which where every element is a matrix, okay, and each matrix has different rank. That is possible. Is it clear? Is it clear?
Yes, yes, sir.
No, it is clear to you, but whoever asked this, I forgot.
Dimension of the R2 and
right. Yeah.
Sir.
1 minute.
Sir,
1 minute. 1 minute. 1 minute. Ashutosh, is it clear?
Yes, sir.
Huh?
Yes, sir.
Okay. Yeah.
Sir.
Yeah.
Sir, I have a doubt in refresher week practice assignment.
Okay. What is your doubt?
Sir, there is a question in practice assignment, question number 1. There is a sequence given, sine of n pi plus cos of n pi divided by n square. So they are asking that is this sequence convergent or divergent? Sine of n pi plus cos of n pi divided by n square.
Okay.
Here they have given hint that use sandwich theorem.
Exactly.
Yes, sir. Then how can we find?
Okay. What is the value of cos of n pi for any n?
For any n, sir, this depends on n.
Okay. So what is cos pi?
Cos pi is, I think this will be -1.
Okay. What is cos 2 pi?
Cos 2 pi is 1.
Cos 3 pi?
-1. 1 -1, 1 -1, this will actually.
So this cos n pi is basically -1 power n, right?
Yes, sir. Yes, yes.
What is sin n pi?
This will be, I think this will be sin pi 0. And
so
sin
will be 0, right?
Yes, sir. This will be 0, always 0, yes.
Always 0. Okay. So this is basically always 0, right? So the
Yes,
function is basically what we are getting, -1 power n by n square, right?
Yes, sir. Yes, yes, yes.
So can I write this -1 power n lies between 1 and -1?
Yes, sir. Yes.
Okay. So n square is always positive, so I can take division by that, right?
Yes, sir. Yes.
So can you tell me how to use sandwich now?
Sir, actually, -1 power n lies between 1 and -1. Then now we have to, when n tends to infinity, -1 and 1 will not changes, but
so it is basically bounded by 1 by n square and -1 by n square, right?
Yes, sir. Yes, yes.
Clear? And
yes,
1 by n square is tending to 0.
Yes, when n tends to infinity, yes.
N tends to
yes.
0. So both the side part, I mean left hand side and right hand side, both of them are going to 0.
0, yes. So this will also be 0, yes, sir.
Clear?
Yes, sir. Yes, thank you. Yes.
Okay. Good.
Sir, in the above, sir, that matrix, that similar matrix, that what you have written there, sir, if I try to calculate the dimension of the vector space, then I construct the basis of that, and then number of element in basis. That so it will 4. Is it 4, sir?
No, it is 3.
So I am getting 4.
Why? This 1, 2, and 2, 1 are equal, right?
This one.
Are equal.
Yeah, but
so what will be your basis?
1, 1, 1, 0.
Why 1, 1? First is this one is 1.
Okay.
This is another one. And this is 1. These 3 will be your basis.
Oh.
Right. This is 1, 2, and 1, 8, 1, 2, and 8, 2, 1 are equal, right?
Yes.
So there is one constraint, and there is total 4 variable. So there are 3 free variable and 1 dependent variable, right?
Right.
So 3 free variables mean the coordinate is 3.
Yes.
Right?
Yes.
Yeah.
And sir, another just small question, sir, although it is very silly, but it's very confusing. This linear transformation in matrix form, sir, for the domain part, there is a basis, and the codomain part, there is also a basis. Okay. So when we are for a linear transformation and is given, and we are trying to construct the matrix. What is the transformation matrix?
Yeah.
So the basis of, say, if I take R2, then the basis is 1, 0 and 0, 1. So
I mean that will be given.
and that will be given. That may be 1001 or some given
some
basis.
other, yeah.
Okay. So what we should do, we will take that basis T of that 10, say standard basis 10 is equal to the image from the transformation equation I got, I will put it, right? And that if that is the image, now we will try to form that matrix with coefficient as what is the image I got, and the basis there we are written, that is the domain, a codomain basis.
1 minute. Suppose I have beta for my domain. Beta is the basis for the domain. Gamma is the basis for codomain. Okay. So suppose there is some V1 and V2. There is W1 and W2. Okay.
Okay.
So I will write T of V1. That will give me some element here. Suppose it is my X1. Okay. Or M1 maybe. Some M1. Okay. So I will write this M1. Now M1 is in this side, right?
Yes.
Now I can write M1 as a linear combination of W1 and W2. Okay, I can write it because any element of this vector space can be written as a linear combination of the elements of the basis. Okay. Similarly, I can do it for V2. This is M2. So this again I can write it some linear combination of this, right? So my matrix will be alpha 1, alpha 2, and alpha 3, alpha 4. This will be our matrix. Is it clear?
Yes, yes, yes. Clear. And sir, when we go the reverse, then we same thing. Yeah. Fine. Sir.
Take the question for someone else. Yeah.
Sir, this M1 and M2 we will be getting from some transformation rule given, is it?
Transformation will be given. Okay.
Otherwise,
transformation is given.
Yes.
And you have to ask, you are asked to find some matrix representation of that transformation with respect to some basis. Then this is the process.
Okay. But so directly, if two bases are given, then if you are asked to find out the matrix,
exactly.
Then TV1 will be equal to W1.
No. TV1 will be some element. You know the transformation, right? So you put the first element in the transformation, you will get some output. Okay. Now you write that output as a combination of the basis element for the codomain.
Okay.
So here M1 is my output for the first V1, and I am writing M1 as a combination of the basis element W1 and W2. Okay. Similarly, I am putting V2 as my input. I am getting M2 as my output. Now I can write M2 as a linear combination of W1 and W2 again. Right. Now I am writing this coefficient as the column. That will be my matrix representation.
To get this M1, M2, either there will be some transformation equation will be given in terms of XY, or matrix will be given. So,
if matrix will be given, then the process will be different.
Yes. Okay.
Yeah, then you have to go back to the process. You have to calculate the backward. Okay.
Matrix given means they are asking for the linear transformation equation.
Yeah.
But sir, this alpha 1, calculating this alpha 1, alpha 2, alpha 3, this will be means, shall I again solve that linear?
Yeah, exactly. You have to solve the linear equation.
Or it will be given in exam in such a way so that we can, by seeing, we can do.
In exam, it will be given in such a way that the solution will not be difficult. Okay.
Like we got a similar question in one of the practice assignment with the basis for domain and codomain remains the same, and we are required to find out the matrices for that.
Okay.
So in that case, what were we supposed to?
Then in that case, their W1 and W2 are basically V1, V2, right?
Yes.
The same thing. So you write that. You write it in terms of V1 and V2. I mean, process is
the but would be T suppose if you are given that V1, V2 are 100, suppose one is given, then what V1 would be 100, and that should be equal to alpha of 100 plus.
Suppose this is given the standard one. Okay. No, I am not taking the standard. I am taking this one. Okay.
Yes, sir. Okay. Yes.
Okay. So I am taking Txy equal to x and x plus 2y maybe. Okay. So this is the linear transformation. So what I have to do? T of 1, 0, I will put 1, 0 first. That will give me 1, 1, right? And T of 1 comma 1 will give me 1 comma 3, right? Now I have to write this in terms of these vectors, right? So what will be this? 0 1 comma 1 and 1 1 comma 1. I have to write 1 3 also in that way. So basically I have to write 3 1 comma 1. So this is 3, and so it is minus 2 1 comma 0. Okay, is it clear, Meena?
Not exactly, sir, because in that question, like it was given a space of 3. It was 1 0 0 1 1 0 and
So I am doing it for space of 2. I mean, that is not a
space of
problem.
2. You are relating the second the space with the first one. That how like 1 0 will get 1 1 if we go
So
for
there you have to solve the linear transformation. You solve the equations basically. Suppose, okay, suppose I have taken this 1 0 0 1 0 1 1 1 0, this basis for both the sides. Okay, you are saying something like this, right?
Yes, sir.
Suppose x plus 2y. I am taking some difficult thing. Okay, so at first you write t of 1 0 0. What is this? 1 0 1, right?
Yes.
Now you have to write this in terms of these vectors, right? This is your v1, v2, and v3.
So alpha, beta and gamma same.
Huh?
This basis you are written, sir. This is
No, they are different. Observe. I have not written same, right? Okay. This is 101. This is 110.
No.
Yes, the
I'm saying, sir, the basis is same.
Basis is same. This is same for both.
Yeah, that's what I asked. Yeah, okay.
So this, right?
Yes.
So what we have to do? So here, if we write this, we will get a plus b plus c. Then it is c. Then it is b, right?
Yes.
So basically, you get 3 equations: a plus b plus c equal to 1, c equal to 0, b equal to 1. If you solve this, you will get some values for a, b, c. Similarly, for the second one, you have to do. Similarly, for the third one, you have to do. Okay.
Okay. Fine, sir. Got
If transformation matrix is given, then how? What is the process to find?
Sir, just one question before.
Before
going. No, before going to the next set, sir, just one question, sir.
Okay.
So go to the previous one, sir, just where you have written the beta. Yes, sir, wait. So this beta you have written here, and the matrix you are calculating here also beta equal to gamma, right?
Yes. Yeah.
Okay. So carry on, sir.
Yeah. Now suppose some matrix is given. Okay. Suppose for 2 vectors, 2 bases are given. I am taking a general case. So 1 0 and 1 1. Let us do for R2. Okay, you can generalize it for R3 also. So suppose here I am taking 1 2 and 0 1. Okay, so 2 defined bases, and with respect to these 2 bases, I have given some matrix representation with respect to beta and gamma. So beta for domain and gamma for codomain. I have got some matrix 1 comma 1 3 2 4. Okay, so you want to find the linear transformation, right? That was your question, right?
Yes.
Yeah. So do it with me. Okay, so what is this thing? So this is my v1, this is my v2, this is my w1, this is my w2. Okay, so what I have found, I have put t v1, and I have got some output here, and that is the linear combination of 1 into w1 plus 3 into w2. That's why this 1 3 came in the first column, right? Is it okay?
Yes, column wise. Yes.
So and tv2, what is tv2? This is 2 into w1 plus 4 into w2, right?
Yes.
Right? Yeah. So what is 1 into w1 and 3 into w2? So 1 comma 2 plus 0 comma 3, right? So it is basically 1 comma 5, right? And what is 2 into w1? 2 into w1 is 2 comma 4 and 0 comma 4. So basically 2 comma 8. Okay. So basically what I got, I got t of 1 0 is 1 comma 5 and t of 1 1 is 2 comma 8. Okay, till now this is clear?
Clear.
Okay, now I want to find what is t of xy. This I want to find out. Okay, so
Yes.
let me write. So t of xy, I can write it as x into 0 comma 1, sorry, 1 comma 0 plus y into 0 comma, okay, so let me do it little differently. Okay, so this one I can write, right? So I can break it down to t of 1 comma 0 plus
So
y.
going with the standard basis order.
Standard basis. Okay, so I can now what I have to do, I want to find what is t of 1 comma 0 and 0 comma 1. This I have to know. Now 1 comma 0 I know. T of 1 comma 0 is 1 comma 5.
Here,
that I know.
you have to use the given basis now, like one.
That I also can do. This is also I can do. Okay, any process you can do. Okay. So I want to write this 0 comma 1 in terms of 1 0 and 1 1. Right?
Excuse me.
Yeah.
It should be y into 1 1.
That also you can do, but no. X
so why we are using the standard basis, because when
so,
the given
okay,
basis
one minute.
Yes,
X comma y, is it same as this?
Yes.
Is it same as this?
No.
No.
Yeah.
X minus y into,
yeah. But if you take some different coefficient a and b other than x and y, then it will not.
Then I can write. Yeah. So there are two processes. I will going to discuss both of them. Okay.
Okay.
So this is the first process where I am writing x y in terms of standard order basis.
Standard. Okay.
And I am trying to write this standard order basis in terms of this 1 0 and 1 1.
Affecting the problem, like
you. But then from where we will getting this t of 0 1 0.
That I am doing right now. Okay.
You are changing it basis to standard order basis to
exactly
affect the transformation. Like
no, observe this what I am doing. Okay. Okay. So I want to write this 0 comma 1 in terms of 1 0 and 1 1. Right.
Okay. Now you will do.
Okay. So it is a.
I lost the track after this interruption. I mean, t x of y equal to x of t 1 0 plus y of t 0 1.
This is okay.
It is clear.
Okay. And now I am using the properties of linear transformation. I can take this x outside and y outside. I can write this like this, right?
Yes, that is also clear.
So now I know the images of 1 comma 0 and 1 comma 1 because that was the basis given to us. I don't know the images of standard order basis, right?
Yes.
But I can write this standard order basis in terms of this 1 0 and 1 comma 1. I can. Okay.
Yes, we can. Yes.
So the first one is basically clear. The first one is basically 1 comma 0 is nothing but 1 into 1 comma 0 plus 0 into 1 comma 1, right?
Yes.
Okay.
Yes, sir.
Now I want to write the second one 0 comma 1 in as a linear combination of 1 0 and 1 1. That's what I am doing. I want to find a b such that a into 1 comma 0 plus b into 1 comma 1 is 0 comma 1, right? So a plus b
you are converting it in that basis only.
Like 1 minute. Let me finish this, then you ask. Okay. So this is clear.
Yes, sir.
Okay. I mean.
Yes.
Clear to everybody. Okay. So b is 1. Now I put b equal to minus a. So our a equal to minus b, you can say. So a equal to minus 1, right? So what I get here, 0 comma 1 is basically minus of 1 comma 0 plus 1 into 1 comma 1, right? So what is t of 0 comma 1? T of 0 comma 1 is minus t of 1 comma 0 plus t of 1 comma 1. Okay, right? So what is t of 1 comma 0? It's 1 comma 5 and t of 1 comma
t of 1 comma 0 is 1 5, which we found otherwise earlier itself.
Exactly. And this is 2 comma 8, right? So what is this? This is 2 minus 1 1 and 8 minus 5, this is 3. So t of 0 comma 1 is 3. Okay, and t of 1 comma 0 we already know this is 1 comma 5. So what is t of xy? T of xy is x into t of 1 comma 0 plus y into t of 0 comma 1, that is x into 1 comma 5 plus y into 1 comma 3. So this is x plus y, 5x plus 3y. This is your linear transformation. Is it clear?
1 sec, please.
Here I can ask something.
Yeah.
So you ultimately use that basis, but directly, not indirectly, like because the value we know at basis only. So
yeah,
you started with the standard order basis, but like ultimately converted the found those values from the
exactly, exactly.
Please scroll up a little. I mean, from the beginning. Yes, please wait.
Will you be providing this in the portal?
This one.
Scroll down, please.
Yeah, this one I can provide.
Sir, just hold on, sir.
Please scroll down a little. I mean, next page. Next, please. Thank you.
Is it clear?
So one down here. So one down.
Yeah.
How we got T of 1, 1 is 2,8.
T of 1, 1 you have calculated here, no?
1, 2, 3, 4.
So this is your image of T of 1, 1. So this is 2 into W1 plus 4 into W2.
Would you please, if you, with your permission, may I complete this process once again?
Yeah, go ahead.
So we are given the standard. Scroll up a little. That T is V2W.
No, it starts from here.
T is a transformation from the domain V vector space to the codomain W vector space.
Exactly.
We are given the basis of vector space V as beta equal to 1, 0 and 1, 1. And the basis of vector space W as gamma equal to 1, 2 and 0, 1.
Exactly.
So we don't, we are also given the transformation matrix, which is 1, 2, 3, 4. Now we have to find the relationship. This is R2 to R2. So we have to find the relationship of T of XY. What will be the relationship in the equation form?
Exactly.
So now with this, we can treat this basis vector V1 and V2 in domain basis, and we can find the image of that those vectors in basis the given transformation.
Exactly.
So TV1 will be, we'll take the first column 1, 3. So the TV1 will be 1 of W1, which because any vector in the codomain W can be represented as a combination, linear combination of the basis of W1 and W2 in codomain. So we are representing TV1 as 1 W1 plus 3 W2. Correct? So which when we simplify, because we have this W1 and W2 given, which comes to 1 and 5. Yeah. So T of 1, 0 is 1 on 5, 1, 5, which we have calculated. Again, T of V2, which is 1, 1. We have calculated like second column in the transformation matrix, exactly. 2, 4. And basis that we have calculated is like 2, 8.
Exactly.
Now, so these are the, please come down now. These we have established. T of 1, 0 is 1, 5 and T of 1, 1 is 2, 8.
Yeah.
Now we have needed to find the relationship T of XY. Now in the XY is in the R2 space. So which we know that the standard basis is 1, 0 and 0, 1. So we can always write X as X of 1, 0 and we can always write Y as Y of 0, 1. So the linear transformation T of XY will become T of X times 1, 0 plus Y times 0, 1, which by the property of vectors, it becomes X of T1, 0 plus Y of T0, 1.
Property of linear transformation, not vectors.
Sorry, linear transformation. So in this last term, we know expression, we know T of 1, 0, which we have already calculated earlier.
Yeah.
No, but we don't know what is T of 0, 1.
Yeah.
So we are expressing 0, 1 as a given standard basis.
Given basis, not standard.
Sorry, given basis in the domain. So 0, 1, we are writing like A times 1, 0 plus B times 1, 1.
Exactly.
And then we solve for A and B.
Exactly.
To minus A becomes -1 and B becomes 1. So 0, 1 is minus 1 times 1, 0 plus 1 times 1, 1.
Exactly.
So T of 0, 1 becomes, we write it like this, minus, because this vector is like this, so transformation will be like T of 0, 1 will be minus of T of 1, 0 plus T of 1, 1.
Exactly.
And this becomes minus of 1, 5 plus 2, 8, because these two we have already calculated earlier. And this gives 1, 3. So T of 1, 0 is 1, 5, which we have already calculated.
Exactly.
So now we are plugging in these two things values in the earlier expression of x times t1, 0 plus y times 0, 1.
Exactly.
Y times t of 0, 1. Here it should be. T is missing.
T of 0, 1.
So this is how we get. This is the entire process.
So I think it is clear to everybody, right?
Any vector, whenever we say image of any vector with linear transformation, we mean that image of the vector in the final matrix. Na?
Image is always in codomain and pre-image is always in domain.
Aditya, what is your question? I have not got it.
Image, when we say image of a vector with respect to linear transformation, we mean the vector in the matrix, na final matrix.
No.
Vector
Image means just image. Image means just image vector.
So that means a transformation vector. The just applying
the image vector. You apply the transformation. What the vector you get, that is your image vector.
Okay, like T10 you have applied. So 1, 5
this is your image vector 1, 5. This is your image vector 2, 8.
Okay.
Image of 1, 0 is 1,
1, 5 and 2, 8 are in W vector space, correct?
Exactly.
And 1, 0 and 1, 1 on which we are applying the transformation, these are in the domain vector space V.
So 1, 5 is image of 1, 0 and 2, 8 is image of 1, 1. Right?
This final matrix is just the representation of the transformation along with the basis.
A representation of transformation with respect to these vectors, these bases. Okay.
If bases are given, then transformation is unique.
Aditya, I am not getting what you want to say. Can you please elaborate it?
So can you explain activity 8.1 question number 3?
What is
one thing I wanted to clear, image dimension is same as rank, right? Rank is same as the dimension of image, right?
Dimension of image. Rank of a transformation is same as dimension of the image space. Yeah, right. Yeah, Reha, what you are saying?
So can you explain
what this question about?
Question number 3.
No, what is this question about? I mean,
we have to find the definition of T.
That's what I was doing here. No, now you try it yourself. Okay, now I think you can do it. I have done the complete process here, right?
Yes.
Yeah, so you can try.
Are there any final suggestions from your end? Like any final suggestions or
solve the mock two papers, both the mock papers. That is the final suggestion. Solve both the mock papers. Okay.
If we
are you providing the solutions of mock?
Solution will be provided today. I think you have got a mail, right? The today's solution.
Yes, yesterday.
Yes, sir. I have one quick question, sir.
Yeah.
If any matrix 2 into 3 matrix is there, and I'm suppose A equal to 2 into 3 matrix, and I'm telling that AX equal to 0, then either it has the 0 solution or infinite solution, no?
Yeah, anyway, Ax equal to 0, that means either it has a trivial solution, that is X equal to 0.
But in solution, one place it's written unique solution. That's I little confused to correlate.
Unique solution means 0. If it has a unique solution, that is the 0 solution only. There is no other solution. Okay. If it has 0 solution, that is also unique, right?
But sir, in solution they solve that. No, they first transpose. Then after transposing, that entire situation changed. No. Can you write that question, sir? It is the row is -1, 3, -5.
1 minute. Huh?
It is the 1 second, so -5.
Okay.
Yeah. Second row is the 2, 1, 3.
Okay.
It is written that system AX equal to B, where the B equal to 0, 0
Okay.
has unique solution.
Huh. So it has a unique solution, right?
How?
It has a unique solution because the solution is 0.
Okay. So in that, in the solution, they reverse it, transpose it. So in that case, I can say that no, it has the, yeah.
If you have to solve Ax equal to B, then you don't have to take the transpose.
Can you go the solution of that? It is the graded assignment 6.
Okay, I think you are asking about some question. So in one question in the portal, it was configured wrongly. I mean, in portal, it was given to find the solution of Ax equal to B, but actually our intention was to get a solution like this. So in
Oh, but
this question,
I think like that question. So here is no. So taking transpose and then finding solution is completely different solution, no?
I mean that, yeah, definitely, because that will be a 3 cross 2 matrix, right?
Correct, and it has only 2 variable X and Y.
Exactly.
But on the top it has 3 variable.
These
So both
these two problems are different.
So that question itself is wrong.
Yeah. We have.
Okay.
I think we have. You know this, right? That question was ignored.
I was not in discussion, so just I was revising. I just got that, and I was. Thank you, sir.
Yeah.
Sir, as you told further about that symmetric matrix basis of that, I thought that what if 3 cross 3 upper triangle matrix, then the dimension of that matrix is 3. But
no. 2 cross 2, right? 3.
No, sir. I'm talking about 3 cross 3 upper triangle matrix.
The 3 cross 3 upper triangle. How many free variables are there?
Free variable A11, yes.
How many free variables are there?
Free variables means.
Okay. So you first go back to the previous live session and go through this discussion. I think free variables means what are the variables here we can change. We can take any values, any real values. So these are all the 6 places where we can put any real values, right? That will give you an upper triangular matrix, right?
Yes.
So the dimension will be 6.
Dimension will be 6.
Yeah. Okay. I mean, we can put any. So what is the basis of this space?
Basis of this space all over 1 0 0 0 0
so
0.
At first position, this
yes.
Is 1.
And similarly others. Okay.
So how many this will get?
6.
So dimension is 6, right?
Sir, but if we take the non-zero rows,
that is different, and that's what I am saying. This is dimension of the space, and you are talking about some rank of particular matrix. Those two are different. How are you relating these two? This is the vector space, okay? This is a vector space with usual matrix addition, okay? Is it clear? Hello? Hello, are you there? Hello? Am I audible?
Yes, sir, you are.
Yes, audible.
So where he is now?
Maybe he has some network issue.
Okay.
Sir, actually my internet connection was unstable. Can you please?
So I am saying this is a vector space, okay, of upper triangular matrices, and you are talking about the dimension of it, right? So dimension of G you have calculated it is 6. Now we are taking a particular matrix from this set. Suppose I am taking, this is an upper triangular matrix.
Yes.
This is an upper triangular matrix. When you are calculating the rank of it, this has nothing to do with this dimension. This is a particular matrix in this vector space, and you are calculating the rank of it. This has nothing to do with dimension of this vector space. Is it clear? This is an element of that space, and you are calculating the rank of it. It can be different. Yeah, observe that this is also a upper triangular matrix. This first one, 1 0 0 0 0 0 0 0 0. Right? What is the rank of this?
1.
This rank is 1. So suppose this is my A1. The rank of A1 is 1. This has nothing to do with this dimension. Okay.
Okay. When we put the values in this place, then the rank and dimension will be different.
Dimension of a vector space. This is dimension of a vector space. This is not the dimension of the matrix. This is dimension of the vector space formed by these matrices. This is the rank of the vector space. This has nothing to do with the dimension of the space. Is it clear?
Okay. Clear, sir. Clear.
Okay.
Thank you, sir.
Yeah. Okay, so should we end this session? I mean, it's nearly 3.5 hours.
Thanks a lot for this session. I mean, really.
Thank you very much.
Yeah, so best of luck for your exam.
Not the question, but just
thank you.
A general opinion from your side. If you just go through all the practice session, the practice assignment and the tutorial videos, would that be sufficient?
More than sufficient.
Okay, tutorial and practice assignment would be more than sufficient.
For the, last minute preparation, I will suggest there is an PDF which is uploaded for Solve With Us, right? A compiled version of Solve With Us from 1 to 8. Just browse through those, browse through that only, and solve the mock 1 and mock 2.
Okay, fine, sir. Thank you.
If you solve this, I think this quiz will be good for you.
Okay. Because see, from yesterday night, I was confused with all this vector space and all this thing. But after going through the practice assignment and the session, the doubts are becoming clearer.
Okay, great. Yeah, just browse through that Solve With Us assignment. I think that will be more clearer in those things. And try to solve the mock. That is really important. Try to solve the mock.
Yes, sir. Going with that only. I've solved one, and I'm going to the second one.
Try to understand each and every problem and each and every step of this mock. We will release the solution today. If you are unable to solve anyone, go through the solution. The solution is written in detail. I have written the solution, so you will get that.
Okay.
So go through that. I think that will be enough for your quiz preparation. Okay.
Thank you, sir. Thank you.
Yeah. Okay.
Thank you so much for the session.
Yeah.
It is great.
Thank you. Yeah.